and grateful to see such distinguished guests, scholars, teachers, and participating delegates. First of all, I heartily welcome all of you on this historic day of the opening ceremony of NCCT 2020 and International WebCon on recent advances in chemical education and chemical research. The program is going to begin with Kulgeet of University, Lalit Narayan Mithila University, by a group of students from MLSM College, Darbhanga, with the consent of the chair. Students, please present the Kulgeet. स्टार्ट करो, अनाउंस कर, अनाउंस करते हैं। हाँ, वॉइस दार न करें, वॉइस दार। अजान कैसा? हाँ, बस जा रही अब अपने से ऊपर में दे। हेलो, ठीक ठीक, मैं दिख रहा हूँ, देख लेता हूँ। मैंने इसको कर दिया तो अनाउंस कहाँ सुन रहा है? अनाउंस करते हैं। हाँ, आवाज नहीं आ रही है मेरे यहाँ पे। नहीं, वो अनाउंस करेंगे ना सुभाष जी।
Subhash sir, please unmute yourself. Subhash sir.
Yes, yes.
Sir, please start this processing.
Kulgeet is over. I think it was not audible. That's why I was just waiting for.
Sir, it's done. Kulgeet, it was audible, sir.
SP Singh, go ahead, please.
Okay, for next. Okay.
SP Singh join कर चुके हैं VCL में
Yeah, well sung, Kulgeet of Vishwavidyalaya. Now, I would like to invite Principal of the college, MLSM College, Dr. B.N. Jha, to present welcome address. Professor Jha.
Good morning, all the persons who are here watching the program, joining the program. MLSM College Darbhanga is one of the premier institutions of higher education under LN Mithila University, Darbhanga. It gives me immense pleasure to inform you that the Department of Chemistry, MLSM College Darbhanga, is organizing a 3 days national convention of chemistry teachers and international web conference on recent advances in chemistry education and chemical research on 29th, 30th November and 1st December 2020. It's being organized on the 20th anniversary of the establishment of Association of Chemistry Teachers. I, on behalf of myself and also on behalf of the chemistry department of the college, am thankful to the Association of Chemistry Teachers Mumbai and to HBCSE for giving us an opportunity to host such a mega event. ACT General Secretary Professor D.V. Prabhu and President Professor Brijesh Pare deserve a big credit for the same. All the distinguished scientists, faculty members, research scholars, teachers, and students participating in such an academic program of National Chemistry Teachers, National Council of Chemistry Teachers, and International Web Seminar on recent advances in chemistry education and chemical research are welcome. The credit of organizing such an event goes to the faculty member and head of the Department of Chemistry in our college, Professor Prem Mohan Mishra, who has taken the initiative of organizing this mega event. Special thanks are due to the speakers from all across the globe, Professor Angela Wilson, Professor S. Chandrasekharan, Professor K. Subramaniam, our Vice Chancellor, distinguished Vice Chancellor, Professor S.P. Singh will be speaking, so just after me, Professor Angela Wilson, etc. Once again, I accord a very warm welcome to all the participants and I wish a grand success to this 3-day mega event. Thank you.
Yeah, thank you, Professor Jha. Now is the time to have blessings from the guardian of the university, the Honorable Vice Chancellor of Lalit Narayan Mithila University, Professor S.P. Singh. I must make a mention that Professor Singh is a well-known academician who served the academic institutions in various capacities in his more than 40 years of experience in higher education. Sir, you are requested to address the gathering, please.
I feel my great pleasure to be a part of mega event organized by the college. I must the principal of the institution, Professor Vidyanand Jha, the organizer of the seminar, Professor Prem, for organizing such events in the banner of the LN Mithila University and the college also, MLSM College. Really, I feel pleasure to welcome to the chairperson and the dignified chemistry faculty members who are going to participate these events today. Really, I must congratulate the departments, the organizing committee to select a very such wonderful topic, relevant topic for the discussion in their convention of the chemistry teachers 2020. And the international webcom, the topic is that recent advances in chemistry education and chemical research. I think the subject chemistry is more useful subject, is more thoughtful subject related to the well-being of the human beings. It's whether related to the biodiversity, even related to the environment science, even related to the medical science, and so many branches are there, disciplines are there. In that way, this subject is being going to help the humanities, the great in the globe. I must congratulate the participants who is going to participate 3 days convention to discuss the different related topics and issues that is going to be the help to the society, to the nations in large. I feel my great pleasure to welcome all the peoples who are going to joining this and supposed to be joined during 3 days of the program. And I congratulate again and hope that the theme of the seminar would just come to conclude the very much interested, very much useful issues that would going to the help in the future to the society and human being. The college is well known, what I have told by the other peoples, the person related with the university systems. It's the excellent college and always going to the being an excellent ladder, one step ahead. And this is the one step ahead moment of this MLSM college in the leadership of the Professor Vidyanand Jha and the support to the head of the departments, Professor Prem Mohan Mishra. I again congratulate and all my good wishes to the people, to the seminar, to the webinars, and to the chemistry conventions. Thank you so much for giving me this opportunity.
And we are certainly energized with the wonderful address by the Honorable Vice Chancellor. Thank you, sir. Thank you very much. May I now invite Professor Brijesh Pare for the presidential remarks, please. Professor Pare is the president of ACT. Dr. Pare has obtained his postdoc research from University of Durban. He is the one who believes in all the three dimensions of education, that's teaching, research, and extension. He is INSA nominated affiliate member of IPAC and has been actively working with Royal Australian Chemical Institute and Royal Society of Chemistry. Presently, Dr. Pare is the HOD Chemistry at Madhav Science PG College, Ujjain. Sir, please address the gathering. Professor Pare.
Thank you, Professor Singh, and I'm audible, huh? Okay. Good morning to all of you. Honorable guest, Professor Angela Wilson, a John Hanna Distinguished Professor at Department of Chemistry, Michigan State University, Michigan. Now she is recently the elected president, American Chemical Society. Professor K. Subramaniam, the director, Homi Bhabha Research Center, Science Education. S.P. Singh, Vice Chancellor, LNMU, Darbhanga University. Professor D.V. Prabhu, the founder, General Secretary of Association of Chemistry Teachers. Professor Priyam Mishra, the convener of this NCCT 20. The past president, Professor Sudha Jain of ACT, Professor Samant, S.P. Singh, and all the dignitaries, all the professors, researchers across India. It's a great morning. It's a great pleasure to have you all today on the occasion of a National Convention of Chemistry Teachers 2020, an international WebCon on recent advances in chemistry education and chemical research. So for another 3 days, 29, 30, and the 1st of December, we are going to have a lot of deliberation and discussions on and around the topic in virtual mode. This year, 2020, is very special due to pandemic across the globe. But it's quite special for ACT as well, because we are into 20 years of our establishment. And this makes the event an occasion of huge celebration of 20 years of ACT in the service of chemistry fraternity. The Association of Chemistry Teachers, we call ACT, was launched in 2000 to serve as an apex national body of chemistry educators to promote excellence in chemistry education. The idea of formulating ACT was conceptualized by Homi Bhabha Center for Science Education, TIFR Mumbai. I'm personally and on behalf of ACT very thankful to HBCSE for this contribution. Honorable Director, Dr. Subramaniam is here, and I extend my thankfulness to her. The association brings together on a common platform various college, university, and professors and scientists, researchers from industry, and of course, school teachers also. So ACT has covered, of course, over the years, a significant distance in 20 years. But we have to be sufficiently ambitious, and therefore we will have a scope to traverse long. As far as these 3 days are concerned for NCCT, which is an annual function of Association of Chemistry Teachers, thanks to the pandemic, particularly, that we are going to have really a galaxy of academic stars, across the globe for these 3 days. Otherwise, earlier, when you are doing it in a physical mode, in one place, it would not be possible to bring, to all these kind of people at one platform and in another, in just 2 to 3 days. Now, next 3 days, Professor Angela will be speaking. Professor Subramaniam is with us. Then Professor Peter Mahaffey from King's University, Edmonton, Canada will be here. Dr. Biswajit Saha, Professor Shiva Sarup, IGNOU, Nagpur. We will be having Professor Javier Martinez, who is just an IUPAC president-elect from Spain. Professor Tom Welton from Imperial College London, the president of Royal Society of Chemistry. We'll be having Ankush Gupta as a speaker. Dr. Venkat Narayan, we have Professor Saurav Paul from IISER Kolkata. Professor Shivraman from INSA, IISER Pune, Professor Ramaswamy from Mauritius, and Professor Andy Gravitt from the University of Brighton, UK. I wish to have a quite interactive and extensive deliberations in the next 2 days to come. Particularly the 21st century, although we are into the 21st century, but still a long time to go. So to inculcate 21st century skill among the students, a lot of serious and extensive deliberations of all the stakeholders is required, and I hope this platform will give this opportunity. I take this opportunity to request Professor Angela Wilson to take ACT, that is Association of Chemistry Teachers, along with all the ACS, American Chemical Society academic programs in India. ACT would love to collaborate with ACS for various events ACS going to do in India. We look forward to look into the possibilities of this. Professor Angela, ACS and ACT, so there are 3 letters and 2 letters are common, that is almost 66% we have common, and the T of ACT comes immediately after S. So we are quite close, and we are looking forward to have very closer ties in the years to come, ACT and ACS. Thank you very much. Thank you for joining us, and looking forward to have wonderful 3 days. Very wonderful. Thank you very much.
Thank you very much, Professor Pare, for your well-delivered briefing. We are now eager to listen to Dr. D.V. Prabhu, the General Teachers, care of Homi Bhabha Center for Science Education, Mumbai. Dr. Prabhu is the former head and adjunct professor, Department of Chemistry, Wilson College, Mumbai. Prabhu sir, you are requested to brief this session about ACT. Dr. Prabhu. Dr. Prabhu.
Sir, unmute yourself, unmute. Sunny,
Sunny, I think Prabhu sir is muted.
Sunny, please unmute. Mishra sir,
Yes, sir.
please ask Sunny, let us see what is happening with Prabhu sir. Prabhu sir, please unmute कर लीजिए.
Prabhu sir, you have to unmute yourself. I have provided you rights, but you have to unmute yourself at your end. Okay. Sir, I am just
Okay.
Yes, sir, you are audible, sir.
Yes, sir. Good, good.
Good morning, Professor Angela Wilson, Professor Subramaniam, the other eminent faculty of our convention, and all the delegates of the National Convention of Chemistry Teachers and the International Web Conference. A very warm welcome to the delegates and the faculty to the National Convention of Chemistry Teachers and International Web Conference on recent advances in chemistry education and chemical research, organized to celebrate 20 years of the activities of the Association of Chemistry Teachers. A special welcome to all the distinguished speakers from India and abroad who will be deliberating on some of the frontier areas of chemistry and chemistry education in the next 3 days. We are indeed very happy that you could be a part of our national convention and international web conference. Since its inception in 2000, the Association of Chemistry Teachers has been in the forefront of promoting excellence in chemistry education and research by organizing subject-related activities for teachers, researchers, industry, and students. I may mention some of the activities: conferences and training workshops all over India, and also some international conferences in collaboration with Royal Society of Chemistry London and the Department of Science and Technology, Government of India. Chemistry competitions for students, including a concept test in chemistry for the graduate students. Active participation in the Indian National and International Chemistry Olympiad programs. This year, in the midst of the COVID pandemic, we could organize 31 webinars all over India and started 2 new activities: a workshop on designing quality equations and a research convention, which were great successes with a large participation. The association also has awards for the best teachers. And every year we give about 8 awards during the annual convention. I'm happy to tell you that all the eminent chemical scientists of India are honorary members and patrons, including Professor C.N.R. Rao, the doyen of Indian chemists. NCCT 2020 is possibly the first convention in which we are having several eminent scientists from abroad giving lectures. It's a great honor that Professor Angela Wilson, President-elect American Society, has consented to be the chief guest and to deliver the keynote address. Madam, we would like to take this chance to request you to think of having some close collaboration with our association to organize chemistry activities in our country. We would like to learn from you and organize some joint ventures like conferences or workshops so that our people can get an exposure to the work going on abroad. I am very happy that Professor K. Subramaniam, Director of the Homi Bhabha Center for Science Education, has consented to be the guest of honor. Professor Subramaniam has always been behind us in all our activities, and I would like to thank him for his support at all times. In this workshop, the participants will get a first-hand exposure to the latest in chemistry and chemistry education. And I would like to thank Professor Prem Mohan Mishra and all his colleagues, especially from the East Zone of our association, for the planning and organization of the convention. Finally, I wish all the participants fruitful interactions with the illustrious faculty. You have my best wishes. Thank you very much.
Thank you very much, sir. Thank you very much for your well-delivered briefing. Now, Professor Prem Mohan Mishra, the nucleus of the program, is invited to talk about the conference and NCCT 2020. Dr. Mishra is the ACT Zonal Vice President of East Zone and the convener of the program. Mishra ji belongs to the Department of Chemistry, MLSM College, Darbhanga. I would like to invite Professor Mishra to brief the August gathering about the NCCT and International Conference. Professor Mishra.
Thank you, Subhashi. Very good morning to all. Respected Chairperson, Professor Brajesh Pare sir, our learned Vice Chancellor, Professor S.P. Singh sir, Chief Guest of this program, Professor Angela Wilson, President-elect ACS USA, Professor K. Subramaniam sir, Director HBCSE, Professor Chandrasekharan sir, our Founder General Secretary, Professor D.V. Prabhu sir, all the dignitaries from across the globe and our participants. Actually, I am very much delighted to organize this program. I must thank ACT EC and especially our General Secretary and President to give me this opportunity to organize such a mega event. I would like to thank all those resource persons who have kindly consented to participate in the program and give their lectures. Dear sir, I am delighted to see the galaxy of star speakers like Professor Angela Wilson ji from USA, Michigan State University, and President-elect of American Chemical Society, Professor K. Subramaniam sir, Director HBCSE Mumbai, Professor S. Chandrasekharan, SERB Distinguished Professor of Indian Institute of Science, Bangalore, Professor S.P. Singh, learned Vice Chancellor, LNMU Darbhanga, as the guest of honor, Professor Peter Mahaffey, the King's University, Edmonton, Canada, Dr. Biswajit Saha, Director Training, CBSE, New Delhi, Professor P. Sivasarup, Regional Director, IGNOU, Nagpur, Professor Javier Garcia Martinez, University of Alicante, Spain, and President-elect of IUPAC, Professor Tom Welton, Imperial College London, and President, Royal Society of Chemistry, London, Dr. Ankush Gupta ji from Homi Bhabha Center for Science Education, Dr. Venkatesh Narayan, Principal Polymers Consultant, Infra Technologies Consulting, Texas, USA, Professor Saurabh Pal, Director, Aisher, Kolkata, Professor S. Sivaram, INSA Senior Scientist, Aisher, Pune, Professor P. Ramaswamy, University of Mauritius, Professor Andrew Chandler Grivat, University of Brighton, UK, Professor Nageshwar Rao, Vice Chancellor, IGNOU, and Professor Dolly Sinha, Pro Vice Chancellor, LN Mithila University. All these persons are gem of our chemistry fraternity, and it is our privilege to have these persons as our resource person. During this program, various parts of chemistry, education and research both will be covered, like chemical education, research and the chemical enterprise, the key to our future. Ethics in research and publishing, chemistry education today for our 2050 world. Technology-driven education in 21st century. Chemistry evolves, so should chemistry education. A quest for relevance in chemistry curricula, advances in polymer blends, innovation in science research and education, interdisciplinary approach, future of chemistry and its impact on education, graphite, graphene and what next, and improving classroom assessment. That very important component of chemistry education is the classroom assessment of students, improving classroom assessment and developing teachers for assessment literacy. These are the focal theme, the main topics to be discussed during 3 days. Just you can see how concerned we are about the chemistry education and research. We are going to discuss about our future planning, our technology, our assessment processes, our research ethics, and it will be a boon for our incoming generation, the incoming teachers and research scholars and students. During this session, we are going to award 6 working teachers of chemistry and 2 superannuated teachers. Just in this ceremony, our founder General Secretary Dr. Devi Prabhu will announce the name, and their biography, their messages and photo will appear in the souvenir, and I will send it to you. In addition to that, we are going to publish a ACT 20 years commemorative volume edited by Dr. Umesh Chand Jain ji, and that will be released today in the hand of Director HBCSE Professor K. Subramaniam sir. Souvenir of this program will be released by Miss Professor Angela Wilson ji, and a unique periodic table constructed by our Subhas ji, Secretary East Zone ACT, and that will be released tomorrow by the IUPAC President Mr. Martinez sir. So friends, I request you all to be in the program for all the 3 days, interact with our learned resource persons, and take benefit of the program organized by our Association of Chemistry Teachers, Mumbai, and hosted by MLSM College, Darbhanga. I hope Subhasji came, so probably time has elapsed. I hand over the program to Subhasji. Thank you, sir. Thank you.
Thank you, Professor Mishra, for your briefing actually. Now, let me have opportunity to invite the chief guest on the occasion, Professor Angela A. Wilson from Michigan State University, Michigan, USA, to inaugurate the function and to release souvenir on NCCT 2020, an international conference. Professor Angela is the John A. Hanma Distinguished Professor of Chemistry. She is also the Associate Dean for Strategic Initiatives in the MSU College of Natural Science and the Director of the MSU Center for Quantum Computing, Science and Engineering. She is the President-elect, American Chemical Society. Angela Wilson, you are welcome, madam.
Thank you so much. I am so honored to have the opportunity to participate today and to be invited. I very much appreciate it. And I want to certainly acknowledge all the distinguished guests that are here today, and Dr. Prabhu, Professor Mishra, Professor Pan, Professor Subramaniam, Professor Singh, Professor Zhao. I very much appreciate all the work that you have done, your talks. I appreciate very much acknowledge Professor Mishra for uncanceled over this past year, and I really put this meeting and having such great attendance. Thank you so much. So if I'm a little slow, my apologies. It is 1 a.m. here, but I will do my best today. I am really delighted to be here again, and my esteemed colleagues, I really thank you for this opportunity. I'm highly honored, and today I really look forward to the discussions that we will be having about the future of the chemical enterprise and how our teaching and research, as well as how we engage with our students, is so important for our future. Our future has been shaken up with COVID. However, this should not alter our pathway in terms of moving our field forward. And in fact, it enhances new opportunities and ways to engage our students and our community in the chemical enterprise. This experience is showing that what we can accomplish as chemical scientists and is empowering us towards even greater global connectivity. We do have multiple challenges to face in going forward, and one of these is ensuring the importance of the chemical sciences and science in general resonates across the non-scientific community, not just in times of COVID, but beyond this period indeed. A part of this is in making sure that the workforce of the future, both our current and our future students, are well prepared for our changing world and whatever may come in the future. With the rise of technology and very fast emerging technology, we must make sure that our future chemical workforce is not only well-equipped in chemistry, but also well-equipped to embrace technology along with our vital chemical sciences. Across the globe, there are gaps in the education and training that we provide to our students universally. We can all learn from one another, and I look forward to the opportunity for the American Chemical Society and ACT to collaborate in the future. Congratulations on 20 years of this wonderful organization, and I look forward to hearing much more about it and the work that you're doing over the next 3 days. And with that, I first of all want to thank the organizers for putting together such a wonderful program, as well as the wonderful souvenir, and I hope somebody can put that on the screen. And I also want to excuse me for not having a great light to light up, but I do want to open up this program today. Thank you so much.
Thank you.
Professor Mishra, Professor P.M. Mishra.
Mishra sir, please unmute yourself.
Yeah. Yes, sir. Yeah. Sir?
Professor Mishra.
Yes, sir.
Yeah, on screen, please exhibit the souvenir.
Check. No.
Good grammar and spelling are important, but if you want to write essays that inspire, messages that forge brighter connections, and emails that get the job done,
मिश्रा सर प्लीज जो विंडो है उसे बंद कर दीजिए
spelling.
यूट्यूब वाला.
This sentence is grammatically correct, but it's wordy and hard to read. It undermines the writer's message, and the word choice is bland. Grammarly's cutting-edge technology helps you craft valid, understandable writing.
Please minimize this Zoom screen and then shift to yeah, it's now shut it down.
Grammarly works where you work, on your
What we download now?
Professor Mishra, I think you have to stop sharing and then share the other screen. You can stop sharing,
Okay.
then share the others.
Should we proceed, Professor Misra? Should we proceed?
Yeah.
Okay. Thank you, Professor Angela. Now is the time to request Professor K. Subramanian, Director, Homi Bhabha Center for Science Education, to release ACT Footprints, 20-year release of 20 years of ACT commemorative volume. Professor Subramanian, the area of his research is cognitive aspects of mathematics learning, mental representation in reasoning and problem solving. He has wide experience in the field of education. Professor Subramanian has obtained his PhD from IIT Bombay and lots of publication in the field of chemical research, education and research. I would request Professor Subramanian to release the ACT footprints, please. Professor Subramanian.
Thank you, Professor Singh, and I'm very happy to release the commemorative souvenir or volume on the occasion of the 20th anniversary of the founding of ACT. I don't know what this involves in terms of online release. If you like, I can share my screen and show you the volume which I have open on my computer. Would you like me to do that?
Yes, sir, please.
Yes, sir. Yes, sir.
Yes, sir, please.
Okay. So I hope you can see that.
Oh, that's good.
Yeah, that's good.
I think, yeah, in a changed world now, like, sir. Yeah. Thank you, Professor Subramanian. Yeah.
So it's a really lovely souvenir.
Yeah.
And it's got lots of pictures and illustrations. I think it conveys some of the emotional content associated with the completion of this long period of 20 years, a very successful activity.
Thank you, sir.
Message. So I'll stop sharing, and would you like me to speak a few words?
Yes, sir. Yes.
Certainly.
Please.
Okay.
Please go ahead, sir.
Okay. Thank you. And it's a great honor to be present on this occasion. It's a momentous one indeed. 20 years of completion of Association of Chemistry Teachers, extremely important institution in the country from the point of view of chemical education. And I'm honored to be here. Professor Brijesh Pare, President of ACT, Professor Prabhu, Secretary, Vice Chancellor Professor S.P. Singh, Principal Dr. Jha, colleague Dr. Mishra, Chief Guest of the Day, Professor Angela Wilson. It's a special occasion having your presence, and great to be a part of it. Professor Samant, other dignitaries who are present today, thank you so much for having me here and giving me this opportunity. I'd like to commend and congratulate the association for a successful run of 20 years. I think you've been one of the active teacher associations in the country with very regular programs. And I think by and large, the vision that was behind the initiation of the association, behind the start of the association, has been largely met, and it's wonderful. From the Homi Bhabha Center perspective, of course, we have played a role in facilitating the founding of these institutions, these associations, the Chemistry Association of Teachers, the Association of Biology Teachers, and very recently, just about 2 or 3 years ago, the Association of Mathematics Teachers, the Mathematics Teachers Association of India. We see these institutions as extremely critical in playing a specific function, which is of bringing together on a single platform teachers at the school level, teachers at the college level, university academics, research scientists, research chemists, and people who work in the field of education generally. And I think that this is therefore a very important association in going forward into the future for the nation as a whole. This is my belief, and there are now multiple associations. They're playing an active role, and I'm sure that they will grow in future and become the pillars of both of education in the broader sense of preparing a new generation of chemists or citizens at large. I think this is a very really important role to play. Of course, we are in very special times. The COVID pandemic has shaken a lot of things. It has also inflicted a cost, a great cost on the country, on many sections of the population, particularly those with very little resources. And in a country like India, it's been particularly severe. I think many institutions have tried to rise to the occasion. ACT is one of them. It has adapted, it has changed its programs, and it's changed its mode of functioning. And this is very good. I think it augurs well for the future when we may see a lot of changes in the post-COVID era in terms of the use of modes of communication, the modes of participation, even the programs themselves, and so on. And of course, it's also a big challenge for the scientific community as a whole, which includes teachers of chemistry, teachers of science, of how is it that we bring science to play a really useful and functional role in times of crisis like the pandemic. I don't think we have understood that very well. There have been lots of attempts, but we will probably learn more as we go into the future. Finally, on the occasion of the 20th year, 20 years is a very long time span in an individual's professional life. It's more or less the bulk of one's professional career, one could say. But in terms of an institution, of course, 20 years is not very long. But perhaps it's significant still, because it might signify the turnover in terms of generation. I think it's a time when a new generation probably comes in and takes over. The older generation mentors this new generation, and therefore it becomes a renewal of the institution and a fresh lease of life, a fresh release of energy, and so on. And I am sure this is happening to ACT. And I wish it all the very best going into the future. Thank you once again.
Thank you. Thank you, Professor. Thank you for your good wishes, all the good wishes. Now Professor Misra, by now he is ready actually to exhibit, to share on screen souvenirs. So Professor Misra, PM Misra.
Is it visible?
Yeah, it is visible. And we are clapping, huh?
Yeah.
And we are clapping again. Yeah. 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 It is equally beautiful. Yeah.
Okay, thank you,
Okay,
Professor.
sir. Thank you.
Thank you.
Thank
Now
you.
it is the time for announcement of ACT 2020 awards. Dr. D.V. Prabhu is requested to take the charge, please, and for this announcement. Prabhu, sir.
Yeah. Thank you, Professor Subhash Prasad Singh. It's indeed an honor to announce the ACT Awards for 2020. We call them ACT laureates. ACT instituted these awards in 2012 to recognize the outstanding contributions of our teachers to chemistry education and research. I am very happy and proud to announce the awardees for this year. We have 8 awards from the endowments given by the well-wishers of the association. ACT Sri Anupam Sinha Best Chemistry Award, Best Chemistry Teacher Award is awarded to Dr. B.R. Venkatraman, Associate Professor, Periyar EVR College, Tiruchirappalli, Tamil Nadu. Congratulations, Professor Venkatraman. ACT
Congratulations.
Best Woman Chemistry Teacher Award goes to Professor Dr. Rita Das, Associate Professor, JKBK Government College, Cuttack, Odisha. Congratulations, Professor Rita Das. Professor Lalal Singh Award for Best PG Chemistry Teachers from the State University is awarded to Professor Pramila Kumari Mishra, Professor, School of Chemistry, and Director of the Directorate of Distance and Continuing Education, Sambalpur University, Odisha. Congratulations, Professor Pramila Kumari Mishra. ACT Professor Dr. Bhupendra Sahai Saxena Award for Best PG Chemistry Teacher goes to Professor Murthy Chawali Yadav, Professor and Director, PG Courses, Sri Velagapudi Ramakrishna Memorial College, Nagaram, Guntur District, Andhra Pradesh. Congratulations, Professor Murthy. Professor P.R. Singh Award for Outstanding Contribution to Chemistry Education is awarded to Dr. Bimal Ra, Department of Chemistry and Forensic Science Unit, SGTB Khalsa College, University of Delhi, and Joint Director, Guru Angad Dev Teaching Learning Center of the MHRD, Government of India. Hearty congratulations, Professor Bimal Ra. This year we instituted a new award in honor of Professor Pinky B. Punjabi. Professor Pinky B. Punjabi Award for Outstanding Contribution to Research in Chemical Sciences is awarded to Professor S. Anandan, Professor, Department of Chemistry, National Institute of Technology, Tiruchirappalli, Tamil Nadu. Congratulations, Professor Anandan. Every year, ACT honors the superannuated teachers by giving them Lifetime Achievement Awards. And in fact, this was the first award which we started way back in 2012. This year we are having 2 awardees. Professor Ashutosh Ghosh, Vice Chancellor, R.R. Green University, Government of Bengal, former Vice Chancellor, University of Calcutta, and former Senior Faculty, Department of Chemistry, University of Calcutta, Kolkata. Congratulations, Professor Ashutosh Ghosh. And we also have Professor Amarnath Mishra, retired professor and head, Department of Chemistry, TM Bhagalpur University, Bhagalpur, Bihar. Congratulations, Professor Amarnath Mishra. We are all very proud of these great stalwarts who have rendered exceptionally great service to chemistry education and research. The selection committees were unanimous in declaring the awardees. Brief biographical sketches of the awardees are included in the souvenir which was released at the hands of Professor Angela Wilson. Thank you.
Thank you, sir. Thank you very much. Yastu sansarate desan, sevte yastu panditan, tasya vistarita buddhi, stalaib bindu vivavasi. Program is going to end. The inaugural session is going to end now. So I would now like to request Dr. Suresh Kumar Arya, EC member of ACT East Zone, to extend vote of thanks. Suresh Arya.
Suresh has joined or not?
Suresh.
I cannot see him, sir. He is not there.
PM Misra, sir. Dr. PM Misra.
Sir, namaskar.
Yeah.
I think he joined.
Sir, good morning to all.
Yeah.
Honorable Chief Guest, Professor Angela Wilson, President, American Chemical Society, Guest of Honor, Professor K. Subramaniam, Director, Homi Bhabha Center for Science Education, TIFR, Professor S.P. Singh, Vice Chancellor, LNMU, Darbhanga, Professor Brijesh Pare, President, ACT, Principal V.N. Jha, MLSM College, Darbhanga, and our most valued invited guests, ACT members, and dear participants. It's my privilege to have been asked to propose vote of thanks on this occasion. I, Suresh Arya, Faculty, Department of Chemistry, JNRM, Port Blair, Andaman, EC member, ACT East Zone, on behalf of Association of Chemistry Teachers and MLSM College, Darbhanga, and on my own behalf, extend a very hearty vote of thanks to all speakers for sharing their findings and opinion with us. A big thank to Professor Angela Wilson, President, American Chemical Society, USA, for her efforts towards success of the convention. May I like to express our sincere thanks to Professor K. Subramaniam, Director, Homi Bhabha Center for Science Education, TIFR, for sparing time with us from his busy schedule. I also wish to express my gratitude to Dr. D.V. Prabhu, General Secretary, ACT, for providing encouragement and support for this webcon. Finally, I would like to take this opportunity to place on record our hearty thanks to Professor P.M. Misra, Convener, Vice President, ACT East Zone, and Professor Subhash Singh, Zonal Secretary, ACT East Zone, for the perfect logistic support and guidance to all of us for this occasion. Once again, I want to state that we are all most grateful to all speakers of this webcon. We thank you for being with us. Thank you very much. Namaskar.
Yeah, thank you, Arya. Thank you, Suresh.
Thank you, sir.
So formal inaugural function is over. Now we'll be going for technical session. So with the consent of chair, should we move to technical session, sir?
Yes, sir. Yes, sir.
Now it's the time to invite stalwart in chemistry, Professor S.D. Samant, former ACT president. I would like to hand over mic to Professor Samant. S.D. Samant, sir. Samant, sir, will be chairing the session. Samant, sir, is connected or not?
He looks to be connected. Yeah, he's there.
Saman sir, please unmute yourself. You are, I have provided you co-host, right? So now you can unmute. Yeah, thank you, sir.
Oh, thank you. I got it now.
Yeah, you are audible, sir.
Yeah. And I'm thankful to the organizers for giving me this opportunity to chair the first session. In this session, there are two speakers, and I am very happy to introduce them in succession. The first speaker is Professor Angela Wilson, who is the president-elect for 2021 for American Chemical Society, and she is very closely associated for many years with American Chemical Societies in many capacities. Now, Madam is a distinguished professor of chemistry at Michigan State University. She is also the Associate Dean for Strategic Initiatives in the MSU College of Natural Sciences and a Director of MSU Center for Quantum Computing, Science and Engineering. She earned PhD in Chemical Physics from the University of Minnesota and a BS in Chemistry from Eastern Washington University. She was then a postdoctoral fellow at Pacific Northwest National Laboratory. She's recently served as the director of the Division of Chemistry at the US National Science Foundation. And prior to this, she was the Associate Vice Provost for faculty at the University of North Texas. And in this university, she was Regent Professor of Chemistry and founder of and director of the Center for Advanced Scientific Computing and Modeling. She spent 2 years as a faculty fellow in UNT and also spent 10 years as graduate advisor for the Department of Chemistry. She has fellowships of many reputed professional bodies like American Chemical Society, IUPAC, and so many other organizations. She is presently chair of the chemistry section of the American Association for the Advancement of Science, a counselor for American Chemical Society representing the Division of Physical Chemistry. Madam has served as president of the Division of Physical and Biophysical Chemistry of the IUPAC, as editor for Computational and Theoretical Chemistry, and on the editorial advisory boards of the Journal of Physical Chemistry, Pure and Applied Chemistry, and International Journal of Quantum Chemistry. She has done extensive research work in computational and theoretical chemistry spanning many areas. So we are very, very happy and we are lucky that Madam is going to give an address in our NCCT this year. So I request Professor Angela Wilson to start the lecture and give over the virtual mic to her.
Thank you so much for the kind introduction. I'm trying to share my screen now. Are you able to see my screen?
Yes, ma'am.
Terrific. Thank you so much. I am very honored to be here today, and I very much appreciate the opportunity to talk with you today. I was asked to talk, I was told I could talk about my research or talk about the future of the chemistry enterprise. I thought I would really focus on the future of the chemical enterprise. My research area is quantum mechanics method development and quantum dynamics method development. And so I thought that might not be necessarily of general interest today. So my focus is going to be on chemical education, research, and the chemical enterprise, the key to our future. Just a second. So in looking at the global chemical enterprise, today what I'm speaking about is really chemistry and science educators at all stages and ages. In terms of teaching our youngest of students to our most senior students and working with our postdoctoral fellows. I'm talking also about our chemical businesses, from huge industry to, very small companies, the government, people who are doing research and development, basic and fundamental science to applied research, science policy, regulations, safety, law, environment, management, manufacturing, sales, and so much more. We're all important parts of the global chemical enterprise. When we talk about the chemical enterprise, I really like a couple of statements from the American Chemical Society, and one of them is about the mission. And the mission is really one that I think we all adopt as chemists, and it's to advance the broader chemistry enterprise and its practitioners for the benefit of Earth and its people. And we do so much as chemists, truly for the benefit of the world, benefit of the Earth, addressing everything from the environment to health, food, safety, security, so many other issues, so many other areas. And the vision to improve people's lives through the transforming power of chemistry is indeed something that we all strive for. When we talk about the impact of the chemical enterprise, certainly it's very important to think about the economic impact. And so often it's interesting that the public does not think so much of chemistry necessarily until we hit a time of a global pandemic like COVID, but truly our impact is incredible. The chemical enterprise contributes $5.7 trillion to the global gross domestic product, sorry about that, product, and supports 120 million jobs per year. The largest contributor is actually Asia and Pacific chemical industry, with about 45% of the industry's total annual economic value coming from this part of the world, as well as 69% of all jobs supported. This is incredible. It's approximately 7% of the world's GDP. Absolutely incredible contribution. And of course, these contributions change people's lives in so many ways, from clean water, renewable energy sources, advanced medical care, important nutritious food supplies, recycling technologies, liquid crystal displays, without which we could not be meeting today, and the evolution of that. Haber-Bosch process, of course, has impacted the world. Penicillin, statins, Taxol, polythene, carbon nanotubes, solar cells, and the list goes on and on. The world we know would certainly not exist without chemistry. And in moving forward, we look at so many areas in terms of where chemistry is important. We can look at the Sustainable Development Goals, and in nearly every one of them, chemistry plays a very important role. And in fact, for many of them, chemistry is absolutely central. And so we've got a work cut out for us in the coming years in terms of addressing these sustainable goals. But also in terms of future directions. Some of these relate to sustainability and some of them don't, but there are indeed many new areas that we need to be working a lot in. One of them, of course, is the nanopesticides, and this one, of course, relates to sustainable goals in terms of the world food supply. This is an absolute critical area in which a lot of further work is needed. Looking at more selective organic catalyst is, of course, also very important in terms of a sustainable world, in terms of moving forward, in terms of green chemistry. Solid state batteries is another area that's so critical for us to address. And as well, thinking about solvent-free reactions in areas like flow chemistry, reactive extrusion, and a number of other areas which really provide new routes towards new chemistry, improved chemistry. Water harvesting is an area also that we need to do much more work in. There's still parts of the world where we need to do much more, much improvement in terms of water availability. A lot of discussion has been occurring and a lot of work towards using things like metal organic frameworks, using MOFs towards possible solution towards better water harvesting. Of course, directed evolution of enzymes and directed development of new catalysts are also important areas. And 3D bioprinting is also a very important area in which we can now begin to design different replacement to organs, veins, other things. A lot of work is going on in that direction, and it is an area where we need much more work. Molecular design, of course, is also very important. Molecular design, a more strategic design of molecules, of plastics, more based on monomers, again, more environmentally safe approach. Polymers, looking at things like reversible deactivation of radical polymerization, also quite important. And there's so many other areas that are so intriguing in which we need to consider moving in the future and doing much more work on. When we look at the future of chemistry, there's also a lot of challenges going on. One of them is we want to do faster development, and COVID was certainly an example of that, trying to develop very fast solutions, absolute record time. But of course, this doesn't just extend to new drugs and new vaccines. It extends to so many other areas. New processes, trying to move towards sustainable goals very quickly, trying to move towards more green chemistry. We have so much to address in this area towards moving faster. A part of this also is we also not only want things faster, but we also want to have greater accuracy. We want to have greater precision. If we're measuring things like the effect of various pollutants in the environment, we often want to have very precise measurements, greater accuracy. So we have a lot of driving forces in terms of thinking about the future. We want to do a lot more smart design, informed design, trying to make use of the information that we can gain from many different prior studies and bring that together in such a way that we can have much more smart design, informed design, reducing cost of development, reducing the time, again, bringing things much faster in terms of solutions. And of course, we've already addressed greener and more sustainable processes. We also, when we think about the future, we've got a lot of emerging technologies. Some of them have been used, not all of them, but some of them have been used in other industries. In the auto industry, there's been a lot of work on robotics through the years. Robotics has been used for a very, very long time, but in chemistry, it's less prominent. It is still there, but now we're beginning to see it more and more in individual labs. And so there's a lot of work to do in things like automation and robotics, again, moving towards faster, more precise chemistry, and also towards looking at faster chemistry, things like artificial intelligence. We've been doing it for a while, but we can do it better and better. The methods are getting much better. There's more people engaged in this. We also need to think about machine learning, data-driven approaches, really important towards faster discovery, and also really trying to reduce the numbers of systems that we really need to look at experimentally. We still need to look at a lot experimentally, but it does reduce the amount of chemicals we need to use, the amount of time. But again, experiment is absolutely critical, absolutely vital, but these approaches can certainly help in terms of doing new types of design and discovery. Quantum computing, a little newer. We've been trying to do it for a long time, but now over the past few years, we've begun to see the emergence of systems like an IBM that are available for anyone to try out publicly. There's a lot of challenges in terms of quantum computers, but they will open new doors. Now we can not just basically explore with quantum mechanics and computers based upon two states, basically our zeros and ones, the binary number systems. And in many ways, we can think of this as having it on or light off. Basic quantum computing provides us a way of basically having a dimmer where we can have many different possible states, which really are key to this technology. This technology is incredibly difficult. We have a lot of challenges to solve, but already we're beginning to see some possible important uses, particularly in chemistry, for quantum computing. We also may be opening up some very new doors in terms of quantum communication, as well as quantum sensors, opening up many different possibilities in chemistry and the way we do chemistry in the future. And of course, now we've got a new world. Our new world has kind of been forced upon us in many ways over the past year. And this is certainly in terms of communication. We've got much more of a global community now, and we've got to think about different ways we do our communication through Zoom, through Google Classroom, through Teams, BlueJeans, WebEx, so many different options. And we've also had so many different teaching platforms as well that many of us have had to get used to. And we've had to get used to in a very short amount of time. And of course, our students. We're using many different types of medium, but our students are using even more. And this is only a few of them, and they are emerging very quickly. So when we're thinking about the education landscape and the research landscape in the future. We really need to take consideration of all these different possibilities, and there are so many of them, and so many of them are emerging very quickly as well. In fact, when I was preparing this slide, I had to ask my 13-year-old, okay, what have I missed? And she had remarked to me, oh, Mom, you need to include Discord and this one and that one. And so indeed, our youth are learning so many different platforms and may not be using email as much as we are. And we need to think about how we need to be communicating with them in the future and also communicating about our research in the future. So when we look to challenges in terms of preparing the future workforce, we certainly have a lot of different challenges. I've already mentioned moving towards faster, greater accuracy and precision, smart informed design and green chemistry, sustainability, but also we've got a lot of challenges in terms of increasing multidisciplinary approaches. These are absolutely incredibly important to a lot of the challenges that we're facing in terms of chemistry in the future. We need to really have ways to basically not just train in very specific areas. We need to really provide opportunities for students to become trained in many more areas. We've got a shrinking world. We've got increased globalization, much easier communication, which opens up a lot of new opportunities as well. I've already indicated we have so many different technology platforms, and they are emerging very quickly. And so we need to really work towards preparing the chemical workforce for working on many different platforms and being able to learn about them very quickly and implement them very quickly. There is a lot to do, and this is opening up a lot of incredible doors for assessment as well. Our chemistry educators who are doing assessment are so incredibly important because now we've got so many different variables in terms of, how do we teach our students and how do they learn best? There's so many different platforms we can use and so many different areas that we need to make sure that we are addressing for the future workforce. For traditional education, this is the way so many of us have been trained, and it has been very effective for many years. We've been very focused on our field, very focused on an area, but truly the way we've been trained, it really leaves very little time, or in some cases, no time or opportunity to really include other disciplines. We've learned more about these other disciplines as we have kind of progressed throughout our careers. However, now, as I've already mentioned, many of the problems we need to be solving and having our students solve in the future are ones for which we somehow do need to find some opportunity for other training, not just in chemistry or not just in a branch of chemistry, but really in other areas as well. We also need to have even more experiences for students to be able to do chemistry. Sometimes students have only limited experiences, and we need to have broad experiences in the laboratories, but also have these experiences for students to work individually in labs as well. Sometimes this is hard to do. I started my career at a very small university, and this was very difficult to do in terms of cost, in terms of really having the hours to do this. And for that reason, we really need to make use of some global opportunities to do research, engage in research. A number of different countries do offer them, exchange programs and other opportunities to enable this. And I think that's really important in going forward. And I think it's important for our students to get involved in research and these types of opportunities, not only as undergraduate students, but even prior to their undergraduate years. The scope of what they are permitted to do in some cases has been pretty limited, and we really need to open these doors. I think, about 70% of learning chemistry is about doing chemistry. We can gain a lot of knowledge looking at books, reading, learning from the internet, learning from lectures, but so much we learn is from really doing hands-on chemistry, and this is important. It's really what brings the insight and the creativity to our field, and it is so incredibly important. I think the importance of having chemistry experiences at all levels is just really so vital. In my own career, it played an important role. I worked at the Hanford Nuclear Reservation as an undergraduate student, and I worked there several years. And it was so important for me to have this hands-on experience because it really provided incredible opportunities to really learn about what I liked about chemistry and some things that I didn't want to do as well. And it really is so vital in terms of shaping careers and driving innovation. Now, I'm not going to really talk in detail about my work here, but what I do want to point out is that it is certainly important to include these high school students. and undergraduate students in research. Throughout my career, I've had about 120 high school students and undergraduate students work in my lab. And what I found, initially I didn't give them so many challenging projects to do, but what I found is that they are very highly capable and highly energetic. And here's examples of 2 cover papers from my group. The first one is on the right here, and it's the first one that I list. And Sivabalam, he actually was a high school, he started doing research in my lab actually as a junior high school student. We are doing quantum mechanics. It is not the easiest of topics, but he was an amazing student, very dedicated, and as a high school student was first author on a JPC, a cover article. So we're very happy to see this type of effort. Another student here was not first author, but he certainly put in a lot of time in the project and was also an author of a cover article. And you can see here that indeed we can do a lot with our high school students, and I think we should really strive to provide them with more opportunities as well as our undergraduate students. As educators, we have a lot of challenges. We have a lot of challenges now, once we're post-COVID. We have challenges now indeed, but we're going to have even more challenges post-COVID. And one of them is the fact that our institutions now realize we can do multimode delivery. I think prior to COVID, most chemists were not doing, we're not doing much in terms of online delivery. I did 10 years ago. I think I offered the first 100% online computational chemistry course in the country, in the world actually, and it was very challenging. It was very time consuming. And so I was not actually excited about having to do this again, but indeed, thankfully, processes have improved, but it is still very, very challenging. And now our universities know that we can deliver things online, we can deliver them virtually, we can deliver them in person. And I think one of the challenges in terms of going forward is the fact that we may be expected to continue multimode delivery even post-COVID without necessarily having additional manpower, additional people to work on this. This is a real challenge, and this is something we should make sure that we're addressing with our universities. That is very time consuming to do this type of delivery. And thinking about the future, we need to make sure that that we have enough people to make sure that we can do multimode delivery if that is indeed expected. We also need to go beyond traditional routes for teaching future chemists. First of all, we need to be thinking a lot more in terms of what skills are needed for today's jobs. We need to be thinking a lot more about job preparation and job-focused preparation. What are we still doing that we may not be needed in chemistry education, but we are continuing to do out of tradition? There's a lot of new things that we do need to be fitting into our curriculums. And so a question is, are there some aspects which we perhaps maybe not need to include within our chemistry lab training, within our coursework, that perhaps might make room for new areas of chemistry or interdisciplinary efforts? How do we incorporate that? How do we incorporate new technology? When I was the head of the chemistry division at the U.S. National Science Foundation, I had multiple meetings with heads of chemical companies, major chemical companies. And one of the discussions I had with them was, they were really concerned about having enough people who were not only well-trained in chemistry, but also had very good knowledge in terms of data science and machine learning. And so we really need to make sure that our students of the future are getting this type of knowledge, not only the chemistry training, which really usually fills up a curriculum, but also in these other areas. And how do we keep up with changes in technology? We have a lot of new technology emerging. Quantum computing, quantum communications, quantum sensors could be a part of that. Robotics, how can we possibly incorporate this? There's so many issues in terms of making sure that we as professors are well trained in this or somehow get the training for this, but there's a lot of challenges in terms of cost as well. How can we make sure that our students, the future of the world, the future of truly benefiting the world, benefiting mankind, are well trained in all of these routes that are truly the future of our world? And also, how do we ensure our students are gaining opportunities to get this hands-on training? It is so important. And communication. communication, I think, is going to be an ongoing challenge for us because many of us continue to like to use email. And it was interesting. My dean, a number of us in leadership in my college had conversations with a group of students recently, in terms of their online experiences. And what these students are saying is, hey, we really can't follow the communication. You keep sending us email. We don't communicate by email, and we don't like email. And so, some students are using Discord, some of them are using Twitter, some of them are using, they're using so many different technologies. So how do we keep track of our students in future and make sure that we're communicating in the way that works best for them? And again, I mentioned assessment previously. Assessment is really going to be really important in the future in terms of figuring out what is really needed, how do students learn best, especially if we're in this multi-mode delivery. How are they going to learn best through that? And how do we communicate best with our students? All of these things are challenges for the future, on top of the really challenging interdisciplinary work, as well as the challenges in terms of emerging technology. There's so much really for the future students. A lot of opportunities, but a lot of challenges, not only for students who are learning, but those of us who are teaching them. We also haven't really touched upon other areas. Globalization of chemistry. This is very important to make sure our students are networking, not only networking locally, but really networking on the global scale. There's some great resources out by the American Chemical Society, and I'm sure ACT also has some wonderful resources. How to succeed, how to become an entrepreneurial, what if you're going to start your own business? So there's a lot of things that maybe we can begin to think about how we can provide some additional training for students in some of these areas, which also might be a part of their futures. I did read in Chemistry World, as I was preparing for this, I did read that India does have a new focus on interdisciplinary learning. And I look forward to seeing how this evolves and hearing about your thoughts on this in terms of, I heard that there's going to be a new education policy that may be opening up some new unique opportunities for change and may provide opportunities for more multidisciplinary undergraduate education and revamping of the curriculum. And so I look forward to hearing how this evolves. And truly, it is an exciting time for change. It is very trying to go through change, but it is indeed an exciting time for change. And I look forward to seeing what evolves. So I've spoke a bit about undergraduate education, but I also want to talk about graduate education, jobs and future jobs. Many students go into academia. Far more of our students do pursue positions in industry, in the government, or other types of positions. And the future employment industry of chemistry, PhDs will increasingly be in small companies and startup companies. And so a question is, how can we prepare students for these careers without lengthening the time they spend in graduate school or as postdoctoral fellows? And one of the things I find really disturbing is I talk to many of our alumni, many people who are in the chemistry industry. I've discovered and learned that many of them, the first day in an industrial setting for them was their job interview, and the second day was their first day on the job. I think we need to make sure that our students are getting trained so they are prepared for this. So maybe they have had a taste of industry or a government job or some other type of position before their first day is the interview. Their second day is actually the first day on the job. We think about graduate education and the current structure. First of all, the structure of academic research groups remains focused around single investigators working on one-on-one with graduate students. This model is really not well suited for the kinds of complex systems, types of problems now confronting chemistry. We really need to have teams. We really need to have graduate students benefiting from the advice of multiple faculty. This certainly happens in some places, but not in all. And also not only advice from faculty, but also the opportunity to interact with government scientists, with scientists from industry. This is really important for them to also have the taste of this collaborative environment, working on challenging problems, but also, again, getting this opportunity to experience a little bit of these worlds before embarking on a career. We often have traditional groupings as organic, physical, inorganic, and so on. This really does not necessarily work so well for integrative ideas and problems. The proper way to combine these fields, we're still not quite clear on that. It may be different for different institutions, but it's really important to have interdisciplinary groupings that are really going to benefit the field. So not just maybe getting, some experience in organic chemistry, but also looking in other areas, looking at maybe some areas in economics, management, and finance when appropriate. And so this is very much not the traditional way of learning, but it is maybe very important for some of our students in terms of going forward. Excuse me a minute. We look at graduate education. There are a lot of structural challenges. We need to very much connect our investment in graduate school with what's needed for future job, not only future jobs, but future job success as well. We look at an interdisciplinary future. Graduate school is going to unfortunately become harder. Organic chemists, for instance, we're going to need to know about biology and immunology. Physical chemists may need to know a lot more about physics and perhaps some areas of data science and other areas, perhaps even some areas of mechanical engineering or some other areas. As well, we also need to have a much greater focus towards innovation. And most institutions, research, discovery, and development to market is not a focus. We focus on the research part, maybe on the discovery, but we definitely do not typically talk about how to do the innovation piece that actually brings products to market. We often not in every lab talk about patents, how to do that. These are all things that are very important in terms of training. We really need to do much more consortium type of training for big problems. This is really important. And we also need to provide students with experiential opportunities. What I mean by this is maybe having 2 to 3 months in industry or a government lab. I've sent many of my students for these opportunities and they have benefited tremendously. I visited a university many years ago when I was head of the chemistry division at the National Science Foundation. It was actually one of the national innovation centers in chemistry in the US. It was interesting. They had 40 companies that were advising on this institute. And when I met with the team, I said, well, how many of your students, they had 100 students and postdocs involved in this institute. How many of them have had the opportunity to really engage in industry? How many of them have had the opportunity to spend a little bit of time in industry? And of these 100 students, only one student spent about 2 to 3 days working with the company. And they had 40 companies in which they were engaged. It's really important for our students to have this opportunity to be engaged, to get a taste of this. These experiences can be many different ways. They can be global experiences, sending a student to a research and academic lab in another country. It can be government or industrial experiences. It can be research in a complementary laboratory. And the benefits of this are many. Better insight about non-academic or different locations, potential pre-job training, potential job afterwards. I've had a number of students who've gotten jobs after spending some time in, a few months with the company. A lot of great opportunities for networking, for broadening training, and also for new collaborators, not only for the student, but also perhaps for the mentor as well. And so how can a lot of these changes happen? How can we really change education? One of the things that's going to be really challenging is that the demands on the time of the professor and teacher is increasing. This needs to be understood by academic leaders. I've already mentioned this earlier. Technology, of course, is also advancing very quickly. The platforms are rapidly changing. Thus, what we teach, how we teach, also needs to change quickly. Faster routes to achieve training as an educator or researcher are important, and it's really important to identify ways to make this happen. It's not going to always happen through our institutions, and so maybe some of this training and education can be provided by professional societies and partnerships in terms of professional societies. Our postdoctoral fellows, a lot of the things that I've already said about our graduate students also applies in terms of our postdoctoral fellows. we need to ensure that their preparation is broad and that the experience is not only research, but all components needed to success in the next steps of their careers, whatever the career pathway they choose, whether it's teaching, being an entrepreneurial, where they're going to really need to work towards innovation, whether it's having a leadership management position, or identifying ways to be able to gain the support of their science as a researcher. So there's a lot of work that we need to do to really provide new opportunities, taking advantage of how the world is changing for our students and postdocs. It is going to be difficult to provide all the training that's needed for all the exciting future opportunities. We should share in these global opportunities, making use of our societies, ACT and ACS and other societies, and providing the best global and training education and research opportunities for our future generations. So with that, I just want to thank you. I want to congratulate ACT on your 20th anniversary. And if there's time, I'm happy to address any questions there may be. Thank you.
Maybe one or two quick questions we can welcome. Anybody would like to ask question?
Participant, if you have any query, you can just raise your hand and then we are going to unmute you. If you have any query, yeah. Manisha Shukla has raised her hand.
Good afternoon, and it was a really enriching session, Professor Angela. Of course, we thank you for that. My question is that in a country like India, where as per the geographic and economic structure of the country, there are not very many opportunities for computational chemistry. So for the graduates and undergraduates studying in remote areas of the country, is there any plan internationally to support, to give an opportunity? Because as a country, we are one of the youngest country in the world in terms of young youth, and there are plenty of people who are ready to learn, but probably due to lack of n number of opportunities, they resort to the traditional chemistry and they don't move on to the computational chemistry or the chemistry with a lot of technical advancement. So my request is, or my query is, that at the international platform, is there any view, opinion, or talk about such a thing wherein the youth may be motivated to go into such a field?
Thank you so much for that question. I think that's a spectacular question. And actually, I've been involved in IUPAC for many years, and actually IUPAC has not had discussions on that. But I do think it is a very important topic to discuss, certainly. And I guess a question for you is, do these students have access to even old computers or no computers?
Angela is asking question to you. Please reply.
Yes, actually I was muted and I couldn't unmute, therefore I couldn't answer.
I think there is some difficulty in the
right. No, I get it now.
Connection.
Yes. Yes, Professor Angela, there are places where the old school of computers may be available, but that would be hardly 25% of the total population. But there are places where the facility of computers may not be available.
Okay. Thank you. That gives me something, I will speak with, this is something I will definitely look into. And I don't know what can be done, but it's certainly something that where there should be discussions, definitely. So thank you so much for drawing that to my attention. I very much appreciate that.
Thank you for paying a heed to what I really think for my country and the youth in my country who are doing chemistry. Thank you.
Thank you.
Can we proceed to the second speaker? Hari sir, can we move to second speaker?
Yes, sir.
Thank you, madam. Thank you, madam.
Thank you,
Angela, for giving us an overview of the current situation of chemistry and also where it is heading now. At ACT, we are also seriously thinking about these issues and trying to find out how these can percolate to our student community. Now, you mentioned about this national education policy of government or Indian government. I would also like to tell you that the government is also now in the process of framing the new science, technology and innovation policy, which most probably you will get by next year, early next year. Now we are looking forward for your association with ACT, and maybe we can have various joint programs with American Chemical Society and ACT. There are various issues about which we are very, very serious. Our president will agree with me.
Yes, sir. Yes, sir. Thank you, sir.
Thank you, madam, again for your wonderful lecture. Thank you again. Now the next speaker is Professor Chandrasekharan, a very close friend of mine for more than 30 years. He is currently a distinguished professor in Department of Organic Chemistry, Indian Institute of Science, Bangalore. Now, Professor Chandrasekharan earned his BSc and MSc degrees from Vivekananda College, University of Madras, Chennai. Then he obtained his PhD in 1972 from Department of Organic Chemistry, University of Madras, with Professor Swaminathan. He received a Doctor of Science from North Bengal University in 2011. Now, after his PhD, he moved to Harvard University, USA, to work as a research associate with Professor E.J. Corey. He also worked as a scientist at Syntex Research Laboratories, Palo Alto, California, during 75 to 76. Then he came back to India and he started his career as a lecturer in Department of Chemistry, IIT Kanpur, which is very well known for organic chemistry. He continued there up to 1989, and then he moved to Department of Organic Chemistry, Indian Institute of Science, Bangalore, where he served as the chairman of the department and chairman of the Division of Chemical Sciences, and also as Dean Faculty of Science. Presently, he is INSA Distinguished Professor at IISc Bangalore. His major research contributions are in the area of development of new synthetic methodologies, synthesis of natural products and catalysis. He has published more than 250 research papers in international reputed journals. And over the last 4 decades, he has guided over 100 research students. He was the chairman of a task force on green chemistry of DST, Department of Science and Technology, Government of India. Then he was elected member of the Bureau and Executive Committee of the International Union of Pure and Applied Chemistry, IUPAC. He served as the president of Chemical Research Society of India. He was awarded SS Bhatnagar Prize, which is a very reputed prize award of our country, the Silver Medal of Chemical Research Society of India. Then he was J.C. Bose National Fellow of DST and SCRB Distinguished Fellowship. He is fellow of our all top bodies, top association, Science Academy, Indian Academy of Science and Indian National Science Academy, and Third World Academy of Science. Now, I request Professor Chandrasekharan to start his lecture. Professor Chandrasekharan.
Yes.
Yeah. Have you unmuted your mic?
Yes.
So, sir have unmuted his mic. Most probably he's going to share his screen, I think.
Yeah, I'm doing that now. Okay. Can you see the PowerPoint thing there? Can you hear me there?
No, no.
Hello? Hello? Can you see the slides?
No.
No, sir.
No, sir, your slides are not visible yet.
Oh, why is that? I don't know what it is. I have put in.
We can't see the slides, sir.
I'm just trying to see. Trying to see what is right. Desktop. Okay.
Not yet.
No. I'm sorry. I'm sharing the screen, all right.
Professor Chandrasekharan, you have to, oh yeah, it's come.
You coming?
And now it is in, yeah. Now the
Okay,
first
I'm
slide is
sorry.
in.
I think it's taking a little bit of time, I guess, for whatever reason. Okay?
Yeah. Now you can proceed.
All right. Okay, is it fine now? Can you hear me?
Yes, yes.
Oh, okay then. Thank you very much. All right. So first of all, let me thank Professor Saman for your kind words of introduction. And it's really, really nice that I'm able to participate on this online meeting, celebrating the 20 years of the National Convention of Chemistry Teachers, and also, very importantly, the WebCon, International WebCon on Chemical Research and Chemical Education. I must thank Professor Prabhu for giving me this opportunity to talk to you about some aspect that I was interested in, particularly related to ethics and research and publishing. Today, I will talk about that. All of us are scientists working in academic research institution, and we build our reputation as a scientist through what we do in research in our area of work, and try to disseminate the information to the scientific community by publishing our work in journals of good quality. That's generally our idea. The research and publication process is built on trust and fair play, really. Unfortunately, many young researchers of today are not learning enough about the standards of science through research experiences. Science nowadays is, of course, is very fast paced now. Everybody is very busy, minding their own business, busy with their own work. The result has become quite complex, very difficult. And even experienced, established researchers are not able to sit with youngsters, talk to them, mentor them, tell them about the so-called do's and don'ts of practicing science. Science, with the result, we have to actually ask the question, what are the obligations of a scientist to the various facets of the society? First of all, you will have to see that the major obligation that motivate the adherence to professional standards is to the institution where we work and to the colleagues with whom we work. That's very important first. And secondly, the obligation of a scientist to adhere to scientific standards to yourself, because one is interested in advancing in a career, would like to get promotions, would like to get recognition for what you do. Therefore, you have to be fair to yourself and make sure everything is done fair and square. And thirdly, the scientists also have a major obligation to the society at large, particularly when the scientific work is related to the society, it is beneficial to society, and of course, most of the time it is funded by the public at large, to a large extent. Therefore, we have a major obligation to the societies in general. I thought today I will talk about ethics and research in publishing. In the process of doing so, I have taken a lot of useful information from two major sources. One is from Elsevier, the other one is from the National Academic Press. In Elsevier particularly because I used to be an editor of an Elsevier journal for many years. I used to have interaction with authors, reviewers, editors from various countries. And in the process, I found that the information provided by Elsevier on ethics in publication is very, very important. And in fact, the Committee of Publication Ethics, or COPE, has wealth of information about what is needed in terms of practicing science and also for publishing science. And the other major important piece of information that one can look into, where I had taken a lot of information, is published by the National Academy of Sciences, USA, we call On Being a Scientist. It's an excellent monograph talking about various facets of ethics in research and ethics in publication. Therefore, I first would like to acknowledge these two before I go on further. Normally, when you talk about ethics, first of all, you have to kind of define that part. And of course, if you look at the Encyclopedia Britannica, it tells you ethics is a discipline concerned with what is morally good and bad, right and wrong. That's basically what seems to be the best way of looking at it. But when people think of ethics or moral in a general sense, they think, what are the kind of things that distinguish between right and wrong? Very often you talk about the golden rule, do unto others as you would have them done unto you. Or like the professional code of conduct, like the Hippocratic oath the doctors take. First of all, do no harm. These are the most important things that one remembers all the time. And also, very often one looks at the religious creed like the 10 Commandments in the Bible. Thou shalt not kill. These are the kind of things that one always remembers about between good and bad, and so on and so forth. So the most common way of defining ethics then would be norms for conduct that distinguish between acceptable and unacceptable behavior. That's basically what it is. In the area of science, one can actually categorize that into two major factors. One would be called as a scientific ethics, the other one is a publishing ethics. In fact, in this lecture, I would probably talk mostly about ethics related to publication and only touch upon scientific ethics in that sense. In fact, most of the time, the scientific ethics is all taken care of by international, national, and government institutions worldwide. They concern themselves with this because this involves ethics of human animal experimentation, data storage regulation, and setting up of ethics committees in the institutions, universities, so on and so forth. The scope of research ethics, for example, cover all aspects of research, but they're actually foregrounded when the subject of research, if you're talking about human experiment, animal experimentation, then the research ethic becomes very, very critical, very important. There are guidelines for doing that. Again, today, I will probably not touch upon them. But publication, when you look at, that's the one where I'm going to concentrate mostly about ethics in publication. And publications are the way the world sees you, because most of the time, the world, if you're going to be a researcher and a teacher, and you publish papers, they perceive you based on what are your publications, where have you published them, what kind of work that you have published. And the publications are the one which will actually determine whether you get funding for further research or not. Most of the time, the funding agencies would like to look at your record of publication before deciding whether they would like to fund you. And if you're going to be in an academic institution as a faculty, most of the time your promotion from assistant and associate professor and associate professorship, all that would actually be determined by whether you have been continuously active, publishing papers of good quality. That determines whether you're going to be promoted or not. And ultimately, it will actually even determine whether you're going to keep your job or not in the place where you're working. If you are not going to be active, and academically that is, then in that case, you probably may not be able to keep your job as well. So that becomes a problem. Generally, when you want to look at monitoring the publication ethics, this of course becomes a very major part of publication process. And there you are looking at peer review process. And this becomes the responsibility of journal editors in general, editor-in-chief of a journal. And in the process of doing so, they invariably take the help from reviewers from around the world, or you call as referees. And after the publication is done, they look for comments from the scientific community at large to see whether there are any problems with the publication that's already come out. In fact, you can actually see this publication, Publishing Ethics Associate or PEC from Elsevier gives you again a lot of information about what are the kind of things that to be done. And when one looks at the science and scientific publication, invariably one comes across a lot of cases of what you would call as scientific misconduct. That seems to be more prevalent in the last 20, 30 years or so, mainly because of the information that is made available to all of us through internet. So the scientific misconduct is fabrication, falsification, or plagiarism in proposing, performing, and reviewing research or in reporting research results. This is something which has been many, many years ago, back in 1999 by Federal Register. It was mentioned, which is very true. But when you're looking at the kinds of problems that one comes across in terms of scientific honesty or dishonesty that you look at, there are at least 7 major things that one looks at as a serious one. The first one, the top of the list, is plagiarism. Number 2 is the fabrication and falsification of research. Number 3, non-publication of data. Number 4, faulty data gathering procedures. How you collect data, whether they are fair, whether there have been some problems in collection of data, poor data storage and retention, and misleading authorship, and sneaky publication practices. So these are 7 major areas that people worry about. And plagiarism is the one that seems to be a very serious major problem. And therefore, we try to look at what is plagiarism and what are the kinds of issues that one looks at in this kind of case. So when you look at what is plagiarism, according to the people who have given the definition for this, in fact, there's an excellent article that came out about maybe a little over 10 years ago in Nature in 2008. That article was entitled Tale of Two Citations by Hirami and Garner. We talk about plagiarism is appropriation of another person's ideas, processes, results, or words without giving appropriate credit, including those obtained through confidential review of others, research proposal, manuscript, so on and so forth. This is something that one should be aware of, very critical. And when you look at this, presenting the data or interpretations of others without crediting them, that's the most critical part. And thereby gaining for yourself the reward to have been earned by others, that is generally considered as theft. And of course, it will eliminate the motivation of working scientists to generate new data and interpretation. Therefore, obviously, you will have to acknowledge the work of others and cannot obviously present somebody else's work as your own. That's basically what it's all about. And how does the word so-called plagiarism originate in original sense? Turns out, in the 1st century, the Latin word plagiaris, or apparently it's called kidnapper, was used by the poet Martial way back in the 1st century when he complained that another poet had kidnapped his verses. That is one of the earliest cases of what is known as plagiarism. But in 1601, Ben Jonson used the word plagiary to describe literary theft of that similar kind. Therefore, that's the word which essentially kind of stays on now in the system. So what are the kinds of things that normally people can plagiarize and get into difficulties when they do so? They offer words, ideas, findings, writing, graphic representation, computer program. So there are so many things of this kind which are in principle they've been developed, used by somebody, and you kind of put them in your own way. And that becomes a problem. And therefore, these are people should be aware of in terms of plagiarism concern. So basically, whether it is an inadvertent thing or a deliberate passing of others' ideas, words, and phrases as your own, obviously is theft. And that is one of the main message that one would like to get across is you don't copy. And the problem of so-called cut and paste that we have today, that can lead to serious difficulties of plagiarism. If you do that, whether lazily or deliberately, you would be kind of labeled as a plagiarist and of course guilty of plagiarism in the process. And this in fact can be construed as an academic offense and very often can lead to various kinds of problems, sanctions from the institutions, academic and otherwise. That's something we should be aware of. But then you may ask the question, how big is the problem? Apparently, this is a message that came out maybe about 10 years ago. There could be even more now. Apparently, up to about 200,000 articles out of, say, 7 million articles in Medline database. That's about 1.2%, according to the estimate. This is actually, again, the paper that I referred to earlier, The Tale of Two Citations, which came out in Nature in 2008, that says that at least 1.2% of these papers could be duplicate or plagiarized version. But this could be because there are increasing number of cases is possible, or we have better methods of detection of this kind of process. And of course, we have more publicity in the open world of the thing that we live today. Therefore, all this could be possible, but the fact remains there are reasonably large number of publications seem to have problem related to plagiarism. And in fact, this is something the information came out from Elsevier again almost 10 years ago now. And they talk about various issues related to publication problems. And it turns out plagiarism is among the highest among all of them. You can talk about reviewer bias, results misappropriation, research fraud, and duplicate submission, duplicate publication. All these are problems, but it turns out that plagiarism happens to be a very large share of misconduct in publication part. Therefore, what is the solution to this part? How do you handle this problem? Therefore, correct citation is the key to the whole thing. Crediting the work of others, even if it is your own supervisor's work or your own previous work, citation is very important. That's the real clear message that one has to know. So what do you do then? How do you do the citation? Number one in the process, it places your work in the right context. That is important. And of course, at the same time, it acknowledges the finding of others on which you have built your research. That means that something was already known, you have built something better than what was already known. Therefore, you try to acknowledge them first, refer to their work first, and then say this is what has been done by me, by you, and then you do this publication. And of course, in the process, it maintains the credibility and accuracy of the scientific literature. What is, of course, allowed, acceptable is paraphrasing, as we would call them. That means use your own words to describe what has already been said and done. Paraphrasing is restating others' ideas by changing their words, but not copying them verbatim. That is the most important part. If you just simply cut and paste, then you have a serious problem. On the other hand, you try to put it in a different word. The same message comes out, but not in the same kind of word that was originally used. When encapsulating the work of others, when citing a reference, if you use paraphrasing, that is generally an acceptable situation as far as scientific publishing is concerned. However, what is not acceptable is using the exact phrases from the original source without enclosing them in quotation marks. That means you're going to be putting somebody's words and you put in within quotation mark, that means you are referring to something somebody else is saying, somebody else's word. Therefore, that is fine. But if you don't do that, that becomes unacceptable part. Emulating sentence structure, even when you mildly change slightly different words, that is not good enough. It has to be a completely different word construction has to be there. Then only it will be, otherwise it will be unacceptable. Emulating paragraph organization, even when you use a different wording or sentence structure, again, is not acceptable. Therefore, if you do a minor change in the word structure, that will not be an acceptable thing. It will still be considered as plagiarism. And of course, how do the plagiarism is detected? What are the kind of things that are done by publishers? And there are, of course, software solutions are available. This is something which is all publishing houses, whether it is Elsevier, whether it is Springer, all of them use some kind of detection methods for looking at plagiarism. For example, Turnitin, a so-called Authenticate, Turnitin is generally used by universities. There are other things that are available for detection of plagiarism. And the other one that publishers use is what is known as cross-check to find out whether this is already known, what has been used by somebody else earlier, and so on and so forth. And very often when you want to detect this plagiarism, manuscripts are checked against a database of very large number of peer-reviewed articles and donated by publishers. And therefore, one is able to get some idea about whether certain percentage of material has been taken out in the same way from an existing literature. Without going into the detail, they actually try to generate a similarity. When these software provide you a similarity report during the review process. And very often the running a similarity check is very straightforward. One uploads the manuscript and look for a similarity report using this software. And the default similarity report gives the percentage of the text of the manuscript which has overlap with one or more published articles that are available in the literature. But is it all? Is that very straightforward? But the thing that I would like to mention is they should be taken as a general guide. Because if somebody has a high percentage of overlap, for example, a plagiarized test, doesn't mean that it is probably not all bad. Because most of the time, it still could be a legitimate citation, a legitimate bibliography. All this could be similar, and therefore, one cannot find fault with that kind of system. And therefore, very often when you try to exclude experimental portion, for example, and reference section, for example, then very often you may give a percentage of overlap much less than what is originally come. And therefore, one should be aware of this part. If there is a reasonable percentage of overlap or a similarity report, then there is a cause for concern. And very often the publishing houses resort to various kinds of measures to handle this problem. Again, without going into details, they may resort to so-called article withdrawal of the manuscript, retraction of the manuscript, removal of the manuscript completely, or in some cases, replace an article by a completely different one. These are all the consequences of problems related to ethical system. And there are fabrication and falsification of data. There are a lot of things are known in the literature. And again, there are references that you can see where data have been altered. Therefore, people have gone into difficulty. And other important one that you will find is non-publication of data. Very often, this is also called cooking data. That's something which is very serious problem. Data not included in the results because they don't support the desired outcome. That is not a good thing. Some data actually could be very bad data. Again, that's a problem. Bad data should be recognized while you collect, when you analyze, before you put it in your manuscript. And therefore, there's something one should be worried about. And data gathering is very important. This is the most aggravating situation that you will find. If you have a piece of equipment which is faulty, a broken equipment, and you collect data from there, and if you're going to put the results of that, then you could be in difficulty as a problem. And record data accurately, store data in a safe and private place, and most of the places people would request or require at least a few years, sometimes 3 to 5 years, to be available to the scientific community for any time you want to collect it. And data should be stored in its original form at least for 3 years. At least some publishers insist on that part. Data should be available for examination by anybody who is interested in examining them. And confidentiality of participants should be maintained. That's something which is critical. Again, one major problem that most of the time one finds is related to the authorship issue. Then, of course, you may ask the question, who should be an author there? An author is somebody who had made substantive intellectual contribution to a published study. That's basically the major important decision. And what is the kind of order of authorship? You have the first author, second author, and so on and so forth. And this should be a joint decision of all the co-authors. You should be prepared and to explain. And once you write the author, So in principle, the people, the group should be able to explain as to why they have listed the way they have listed. And everybody should be taken into confidence before you submit the paper for publication. And again, there are variations there. Some groups list the so-called authors in the alphabetical order. Some people write the first author is the one that probably has a major contribution to the work and so on. And this again should be made clear to the publisher and find out what percentage of contribution came from X, Y, Z, so on and so forth. This is something that is more prevalent in the present day compared to earlier years. And other part that you will see is the so-called misleading authorship. Who should be an author? Technicians to a large extent. Somebody takes an IR spectrum or an NMR spectrum for you. Would he be eligible to become an author of a paper? Probably not. The technicians do not necessarily become joint authors. Authorship should involve only those who contribute directly to the intellectual content of the paper. That's very important. And therefore, it is always better to discuss the authorship before writing the paper, or at least before submitting the paper to the publisher. And there are two types of authorship problems that very often one encounters. Particularly, I have seen that when I had served as an editor for many years for Elsevier. There are very often you will find these are difficult to handle, but these are the way things are, one should be aware of. So-called gift authorship. Inclusion of authors who did not contribute significantly to study. This may even include a supervisor who probably may or may not have given any idea to the student. Therefore, he probably may not necessarily be included. But that is left to the student to do that part. And other problem that you find in many laboratories is the so-called gifting the author because of hierarchy, expectation, favor from a colleague, for example, to increase his publication. So these are all things, it has to be a self-controlled thing, self-imposed discipline will have to come. It's something which will be difficult for the others, editors, to take care of these parts. This has to be self-imposed discipline, so that only those who had actually contributed to the work are listed as authors. And sometimes we also find what is known as co-authorship. There are no authors who should have been there. The absence is the author. Or sometimes professional writers give help in writing a manuscript. Then, of course, you would say whether they would be co-authors. Maybe they should be acknowledged for their help. And therefore, the problem coming from hierarchical, political, personal reason all should be avoided in situations of this kind. But most of the time, these kind of gift authorship, ghost authorship, are to be handled by self-imposed discipline of the authors themselves. And again, one asks the question, how do you maximize your so-called number of publications? What I would say, unethically. And there are, again, it's not uncommon that you have to remember. One aspect that is very often done is so-called salami slicing. That means one body of work that is published, normally if it is good enough, you publish as one paper. On the other hand, you try to split it into 2 or 3 papers of the same material, and that becomes slicing of a big chunk of work into smaller pieces and publishing. This again is only the authors who have to take the decision. The ethics involved in doing this kind of part will be avoided. And tiling is another one. When you have 2 papers that you publish, publishing sequence of substantially overlapping papers, which means you have the first paper and the second paper, there is a very large percentage of overlap there. Whereas they could have been combined together to come up with only one rather than writing 2 papers which have overlapping data. And the double publishing is even more serious one, publishing the same work or submit the same work to 2 different journals. Obviously, this is not desirable, should not be done, it should be discouraged. This becomes part of unethical issues related to publication. And of course, ethical relationship between a supervisor and a student, because when you look at a student and a supervisor, it is very often you will say the relationship is unequal and hierarchical. The supervisor plays different roles. He is an advisor, he is a mentor, he is a teacher, he is a friend, he is a PI for a project and so on. And therefore, this can lead to conflicts. And this should be looked at carefully and should be done properly to maintain the ethics of scientific research. And students generally should feel free to make their own decisions about research and so on. And they should not be what we call as the coercive, abusive by the supervisor. That's something which should be avoided in situations. And ethical supervision, therefore, for all the faculty, senior professors, it is important that ethical supervision is very critical. It should be non-coercive. You have to nurture the student confidence and skills and give him freedom, give him permission to do things, and try to promote him be an independent scientist on his own. And that is where the magnanimity of the supervisor comes into the picture. Again, when you talk about scientific misconduct, most of the time the misconduct occurs when researchers intend to deceive. Only when you deliberately want to do something which is not correct, then it becomes scientific dishonest or misconduct. Honest, if you are going to have a honest mistake, which very often can happen due to sloppiness, if you don't have a poor record keeping, we have done a wrong calculation, if you have some kind of a bias, or a self-deception even, or even due to negligence. These kind of things need not necessarily be called as misconduct. These are all problems, all right, but they do not be classified as misconduct. And again, you can have a disagreement about the research method, about interpretation of data, and so on and so forth. But these are quite okay, but you have to address this issue as and when they come. Supposing I have a situation, Dr. X, somebody who has discovered an error in a paper that has been accepted for publication in a journal. While supposing the error does not affect the overall results of the work, could be still misleading, for example. But supposing you find out, you have already, the journal has gone to press, it is too late to catch the error before it appears in print. In order to so-called avoid the embarrassment, supposing the researcher, Dr. X, decides to ignore the error, what happens now? One could probably look at X error is something which is decision, if you don't take, is not considered as a misconduct, but you have to make sure that you have to correct the error sometime. Most researchers, as well as many people who look at policies and codes and so on, they will say Dr. X should actually get in touch with the editor of the journal, tell them about the error, and actually publish a correction or an erratum. That is what is expected of that person. What I would then point out is failing to publish a correction of an error that has already crept in would be unethical because it would violate the norms related to honesty and objectivity of research. Therefore, there's a slight difference between not the misconduct, but non-ethical part will have to get to the picture. Therefore, when you look at scientific research, as you will see, research is a social activity. Research is not just a method and a system of organized knowledge. That is true, but it's not that alone. It is a social activity carried out by groups of competing, cooperating, communicating scientists all the time. That's something one should be aware of. Therefore, how do you communicate with people and how do you interact with people? How do you collaborate with people with fairness all the time? Because you have to have a basic trust in the people and you should earn the trust from people in the process. And there is actually 5 years ago, there is a paper that came out in the journal Current Science that is published in India by Ranade and Kumar. The title of the talk of this thing is an Indian Ombudsman Institution for Ethics in Scientific R&D. There's a very nicely interesting article, talks about ethics in scientific R&D. And there are 2 or 3 points that I highlight there. I thought it was important before I close. According to them, they say, this is to quote them, honesty or ethics is about what one does when no one is watching. This is their way of putting it there. And of course, they also ask the question, is there any well-defined system in place in India? Or is it dealt with essentially in an ad hoc manner when you have a problem of scientific misconduct in our society, in our academic system? But again, this is something very difficult to answer because some institutions have a strong system of taking care of these kinds of problems, whereas some other institutions do not have. And therefore, what they advocate in that paper in Current Science is the necessity for an ombudsman institution is the need for dealing with misconduct of science in India. There's something, therefore, the take-home real message is particularly young researchers who are joining academics, and of course not so young researchers who have been around, it is important that you have to be honest, truthful, and fair to the scientific community in which you are doing this work. Therefore, ultimately, what you do and how you are perceived in your work will be determined by these kinds of factors in your scientific practice, as well as in your ethics and publications and so on. And finally, I would like to thank you for your attention. Thank you very much. I would be happy to answer if you have any questions, please.
Thank you, Professor Chandrasekharan. If there is any question, one or two quick questions, I think we can entertain.
Yeah, please.
Dr. Rakhi Gupta, I think, wanted to ask some
Yeah,
questions.
sure, please. Yeah.
Madam Rakhi?
Is that Rakhi from Jaipur?
Yeah. Because
I think I gave a talk in our university a
a
few years ago. Yeah. Yep.
Any other question? If there is no other question, I have a question, sir.
Yeah, please.
That is, you talked about this gift authorship,
Yes.
Or whenever there is a hierarchy, in that case,
yes.
it happens.
Correct.
You may call it forced authorship or a gift authorship.
Yes.
Now, I am concerned, very much about that, and I feel that what is your solution to that in a big institution?
As I said, this is something.
A big institution. This is happening, Can you suggest
solutions? It used to happen more in the earlier years, but it has come down, fortunately. But nevertheless, as I said, this kind of a problem has to come from so-called self-imposed discipline. The person who is in the hierarchically sitting above you, he should have the moral thing to decide that he should not be part of that. Because this cannot come out by a so-called legislation of some kind. It's not going to work very well. Because as you see, it has to come by your own thinking that this is not the right thing to do. See, these kind of things were happening 30, 40 years ago as a routine thing. But it has come down considerably compared to earlier years. But it has come down mainly because people are talking about it and saying that this is not a good thing to do. Therefore, in my opinion, this has to come more by sensitizing people about this and by self-imposed discipline of people concerned. That's the only thing, at least in my opinion.
No, sir, my question has a different angle also.
Yes.
And that is, you talked about this ombudsman,
Yes.
Now, whether in a public institution or even at a government level or maybe society
level. Correct.
Suppose, can you have an ombudsman type of a system functioning so that this can be in a sort of a, not I'm saying forcefully, but by some mechanism this can be curtailed.
Yes, I would
I'm not
think
saying
so.
Stop but curtailed,
Absolutely, I agree with you. Certainly, we don't have one at the present time, as far as I know. We need to have an ombudsman only for these kind of things. Although we have, there are organization within DST and then CSIR, and also with the scientific advisor to the Prime Minister's office. They seem to have some kinds of document prepared for this purpose, but we don't have anything concrete like the one that we are looking at, but it probably may be a need of the hour. It has to be done. I agree. Sure. We don't have that.
Thank you, sir, for your very educative lecture on ethics in publication. Now, this topic has become very, very serious and of great magnitude because the number of publications is increasing very rapidly. And there are various reasons or maybe the conditions under which the publications are made, publications are increased. And therefore, this topic has gained a very serious dimension. So thank you very much for enlightening us, educating us about the ethics involved. In fact, the broader aspect is the whole, as you said at the beginning, the whole ethics involved in research itself, enterprise of research.
Yes.
And the topic which you have covered is extremely important in the present situation. Therefore, I'm really thankful to you for giving this wonderful lecture. Thank you again, sir.
Okay, thank you. I am now stopping my sharing my thing. All right. Okay, I will also.
With that, the session, this first session is coming to an end. We had two beautiful lectures, one by the Professor Angela Wilson and the second one by Professor Chandrasekharan.
Sir, we have a query from Uma Sharma, Professor Uma Sharma. She's willing to ask a question to sir.
to Professor Chandrasekharan.
Yeah, please. Okay, go ahead. Yeah.
Yeah.
Yeah, please go ahead. Yeah.
Yeah, go ahead.
Sir, I'm just unmuting her. Please wait.
Yeah, no problem. No problem. We will wait.
Uma ma'am, please accept. Yeah, that's fine.
Yes.
Yeah, okay, Uma Sharma.
Thank you.
Yeah.
Thank you. And I would like to discuss some point. As UGC has introduced one paper during coursework of PhD.
Yeah.
And that is of 2 credit related to ethics in publications. So I would like to.
Very, very good thing.
Yes.
Very nice.
Yeah. So I would like to ask you, sir, that how we will frame the syllabus and all that, from where we will get such things and for the students.
I told you, I think the 2 most important one that I gave the reference to, one of course is Elsevier has this so-called COPE, the Committee of Publication Ethics. Is a exhaustive document, provides everything that you have to know about this is available.
So it is available online? Okay.
And the second one I mentioned to you is a monograph that is published by the National Academy of Sciences, USA.
You have already mentioned in your lecture, but we will get it from online directly?
Yeah, they are available, of course. Everything is available online. And more importantly, I will also have to mention, which I did not do, and only last year, Indian National Science Academy brought out a book on ethics in science and practice of in research. And this is something which is a relatively inexpensive book available, published by Indian National Science Academy, that details everything about what is important, what one needs to know. That's beautiful.
That is what.
Okay.
Yeah. Okay. Thank you so much.
But
Thank
for
you.
information, the syllabus of that paper is available on net. You see,
syllabus is available, but reference books I would like to know.
Yeah, sure.
Syllabus is already there. UGC has provided the syllabus, but for students, it is very difficult to understand things.
Yeah.
So I'm thankful to Professor Chandrasekhar for advising that book published by National Academy of Science. Thank you, sir.
Indian National Science Academy, INSA. You look at that, you go to the website of INSA, you will get that information, and you can actually even get a soft copy of that, or you'll be able to buy that. It's not that expensive. All right.
Okay. Thank you, sir. Thank you so much.
Sure.
Sir, we have one more query. We have one more raised hand from Dr. Gyanashri Bora.
Okay, sure. Yes.
Gyanashri, please unmute yourself. I have requested you to unmute. Okay, I think, sir, she's not been around there. So I request Samant sir to please continue, sir.
Yeah. Now we are closing the session, and I hand over the mic to Dr. Singh, SPC.
Okay, fine. All right.
Dr. Singh? Paris sir, is he there?
Dr. S.P. Singh.
Sir, I can find him in the meeting. He's still in the meeting, but I think he's not able. His camera is also mute and his mic is also mute. I have requested him to unmute his mic.
Is Professor Mishra available?
And Dr. Mishra? Dr. Mishra is there or not?
Yeah, I'm there.
Mishra,
I'm there.
So please find out SP Singh. Now he has to take the proceedings ahead.
Yes.
If he is not reachable, I think you can.
I hope.
Go ahead.
I hope we have a break.
Lunch break.
For 50 minutes.
Lunch break.
Yeah. And we shall come back at 1:35 for presentation by the participants.
What is the time now?
It is 1:35.
1:37, yeah.
So we have to come back at what time? 2:20, 2:30? What?
We are going late, no?
That is
one. Yeah. Already it is 1:35, sir.
Oh, good. Then we should start, no?
You can keep You can keep a break, but of say 30 minutes, 40 minutes.
Yes, yeah.
Let us have a 5 minutes break and meanwhile find out SPC.
Yes. We should have only 5 minutes break and we should start presentation by participants. And this session will be judged by a group of 3 members of ACTEC.
When is the lunch break?
Vastav ji, Dr. Umesh Chand Jain ji, and Dr. Sudesh Goderao. Sunny ji, please unmute these 3 persons. They will read out the list. List is
sir,
alphabetically.
I request all these parties
to wait for their turn and present their paper within 3 to 4 minutes, maximum 3 minutes. We should thank Samant sir for conducting this session in a very good manner. Sir, thank you very much. And we hope your cooperation in the near future also.
Mr. Sir, can you repeat the names of the participants? Can you repeat the names of the judges so I can allot them host rights?
Yeah, Dr. Amar Srivastav.
Amar Srivastav.
Yeah.
Okay.
Dr. Umesh Chandra Jain.
Umesh Chand Jain.
And Dr. Sudesh Goderao. Already we have sent mail to all the participants and the list is in alphabetical order. So name will be called in alphabetical order. You all remain prepared for your presentation and wait for announcement of your name. And keep ready your presentation.
Yes, sir.
In electronic form. And present it within the time limit of 3 minutes.
Professor Mishra.
Yes, sir.
Will you read out the names of the participants so that we know the sequence? Just read out the name of the participants.
Yeah, I am reading, sir. Yes, sir. Within 1 minute, I am coming.
Dr. Mishra.
Yes, sir.
I spoke to SP Singh.
Yeah.
He is unable to contact. I mean, his connection. I mean, just disconnected.
No problem. No problem.
So now the next session, Professor Sudha Jain will be chairing the session.
Tomorrow.
I don't know. Okay.
Yeah. I am taking care of this session. No problem, sir.
Oh, okay. मैं बोलता हूँ. I will tell you. Yeah. मैं बोलता हूँ. Just one more thing, Sunny.
Yes, sir.
You have to unmute Dr. Sudesh Bhaskar Goderao. You have unmuted some other Suresh. Okay. Yeah. So Sudesh
sir,
Bhaskar Goderao.
I request him to just raise his hand.
Okay.
So be,
no problem.
Yeah.
So Sudesh Goderao has to be unmuted. That is one thing. And sir, Dr. Mishra.
Yes, sir.
So you are starting the presentation. So will there be any lunch time for 5, 10, 15 minutes? Because after the presentation, Prabhu sir is there, na?
Yeah.
We have an executive meeting after that, na?
Yes, sir.
Let us ask Prabhu sir.
We can take a break of 10 minutes. No problem.
You can take 10 minutes and then we can start at 1:50.
1:50, yes.
Yeah, 1:50. Yeah, 1:50. Okay, fine.
Just 1 minute. I would like to read out the names.
Yeah, please read out the names.
Yeah, for today's presentation, it is A. Anand Babu, Amrita Chakravarti, D. Nageshwar Rao, D.T. Sakare, G.M. Uthuraman, Garima Nagaraj, Govind Prasad Chutia, Jay Prakash, K. Kavi Priya, K. Santa, Kedar K. Raut, M. Krishna Karthik, M. Prakash, Mona Parida, Mridusmita Sharma, P. Arthi, P. Sabana, R. Amulyam, S. Arul Murugan, VVKPL Murti, Vasti Ghana, Vijendra Singh, and two more names. YU Rathor, this one only. This is the list for today's presentation.
Okay.
So we should come back at 1:50, okay?
Sir, sir, request, Prabhu sir.
Yes, sir.
Sir, can we just tentatively calculate the time for EC, and that, it can be declared right now. Just calculate, I mean, because we are slightly late. So where, I mean, it will stand, yeah. At what time, the EC will start here? Please unmute Prabhu sir, just can't hear, yeah.
Hello.
Yes, sir.
I think we can start by 3.
Okay, sir. By
Because
3.
We are 10 minutes behind, so 3 o'clock should be okay.
Okay, fine. Thank you.
Yeah. Okay.
Okay, fine. Thank you, sir.
Hello. Amarji.
Sir, they are available. Amar sir is available. Sir,
So let's
I
start
request all the
now.
parts. Yeah.
Will we start presentation now? Amarji, Umeshji, and Godirao sir. Should we start now?
Yes, sir. Yes, sir.
Yes, sir, we are here.
Yeah, good, good. Welcome, welcome, welcome you all. Should I announce the name or you will announce?
As you
As you wish, sir.
as you wish, sir.
No, as you wish. You are the master of this function and this event.
It would be better if you announce.
Okay, no problem. So A. Anand Babu. First name is A. Anand Babu. And second is Amrita Chakrabarti. Remain prepared. A. Anand Babu is there? Not present. Amrita Chakrabarti.
Sir, please wait for a while. I have to find those people and then unmute them.
Yeah, okay.
So first is Anand.
A. Anand Babu.
I request if you, sir is calling your name and you are available in the meeting, just raise your hand. Amrita Chakrabarti is here. She has, yeah.
Amrita, you can.
Yes, sir.
Present your paper. And next is D. Nageshwar Rao. We remain prepared.
Amrita ma'am, you can share your screen.
Yes, sir.
D. Nageshwar Rao is present. Next is D.T. Sakare. If you are present, please raise your hands. Yeah, Amrita, go on.
Yes, sir.
Chakravarti ma'am, please share your screen. Your
Yes,
poster.
yes, sir. I am doing that.
G. Muthuraman is present. G. Muthuraman. Garima Nagaraj.
The screen. Actually, it is in my.
Ma'am, I have provided you.
Actually, I have prepared slide also, but I am not able to. So, as it is in my. Can I share my
Ma'am, you can show it.
Yeah, you can.
Ma'am,
You can show us. Share your slides. No problem.
To rest of the participants, please please raise your hands if you are available in the meeting, whose names has been called by Dr. Mishra. Please raise your hand so that we can unmute you and you can present your presentation.
Whether the screen is visible? Excuse me, sir. Whether the screen is visible? Thank you.
No, it's not. It is not visible. The screen is not visible.
Jai Prakash, Kavi Priya, K. Santa, Kedar K. Raut, If you are present, please raise your hand so you can be unmuted. M. Krishna Karthik. M. Prakash. Mona Parida. Mridusmita Sharma.
Sir, now it is visible. Excuse me, sir.
The screen is visible, but nothing is there on the screen. It is blank. Yeah. Good.
Hello, sir.
Yeah, it is visible now. Go on. Go
Now
ahead.
it's visible, yeah.
बोल दी ना? Yes, it is
Okay,
visible.
now it is showing.
Yeah, it is visible.
Okay. Thank you, sir. Thank you, sir. Yeah, thank you. I'm Amrita Chakraborty, Assistant Professor, Department of Chemistry in College Patna, a constituent unit of Patliputra University. My today's topic is catalyst-free selenization of imidazo heterocycles. Imidazopyridine are widely present in natural product as well as bioactive medicinal compound and also shows optoelectronic properties. And that's why truly known as drug Bijudi scaffold. And these are some of the important compounds which contain these imidazopyridine moiety and having medicinal value. And on the the synthesis, development of new synthetic route for their synthesis and their functionalization has attracted much attention by the chemist. On the other hand, the organ compound important.
Okay, finished?
I suppose
They are
it is.
called D. Nageshwar Rao. Is he present?
Hello.
Next, DT Sakare. DT Sakare, are you present? Sakare is not there. GM G. Muthuraman. G. Muthuraman is there. Garima Nagaraj. Garima Nagaraj. Govind Prasad Chutia. Govind Prasad. Garima is there, but
Sir, Garima is. Sir, they can't unmute themselves since we have force muted them. So, does Mukta? You have Mukta Rajotia?
Garima Nagaraj, please unmute Garima Nagaraj.
Hello.
Yeah. Garima Nagaraj.
Hello, sir. Hello.
Yes.
Hello, sir.
Yeah,
Sir,
please present.
sir, actually, I didn't get any confirmation mail for presentation. So, sir, I am not prepared today.
No problem.
Sir, excuse me, sir. I am Amrita Chakraborty.
Yeah.
Sir, बीच में वो कट गया था. Can I complete? Another 2 slides are there.
Hurry up, hurry up.
Okay, sir. देख सब लोग यही कर रहे हैं. I didn't get any confirmation mail regarding presentation. So it is visible now, sir, again?
Yeah, please, please, hurry up.
Yeah, yes, it is visible. Please carry on.
Yeah, yeah. So, okay. So, incorporation of aryl selenyl group into the indolazepine moiety could have developed some new or incorporate some new synthetic bioactive property as well as optoelectronic property within the molecule. Thinking that its new methodology, where the specificity of our methodology, it is a catalyst first medium under mild reaction condition. It is room temperature reaction. Yield is very high and it is scalable. We perform the reaction in 5 gram and 10 gram scale also, and not only imidazopyridine but also other imidazo heterocycles like imidazothiazole, benzoimidazothiazole also. The reaction was successful with those scaffolds also, and our starting material is commercially available, that is phenyl selenobromide, and here libraries of compound we have prepared with good yield. Here is the probable mechanism, and it is a ionic pathway electrophilic reactions, and the compound was formed and we have published that one. And finally I want to acknowledge ACT platform for giving me opportunity to present here. Thank you, sir. Thank you very much.
Govind Prasad. Yes. Govind Prasad is there. Please unmute, sir. Govind Prasad, are you going to present? Govind Prasad, are you ready to present your presentation? Jayaprakash is not there. Kavi Priya is not there. K. Shanta Kallu. Are you ready to present the paper? K. Shanta, please unmute yourself.
We have Shanta Kullar, but she's not unmuting herself. I have requested her to unmute herself.
K. Shanta is not present. Kedar Keraut. Kedar Keraut is there.
So Garima hasn't submitted her.
Yes, she is not ready.
She's not ready. Okay.
M. Prakash. Mona Parida. Mridusmita Sarma. P. Arthi. P. Arthi is there. P. Shabana Palyam.
Hello, sir. Hello, sir. Can I present? Can I present, sir? Can you please allow me to share the screen, sir?
Yeah. Sunny is unmuting you.
Sir, I'm Shanta. Can I share my screen, sir?
Sure.
Sir, host is disabled to unmute. There is screen sharing is not possible, sir, for me. I'm unable to share my screen, sir.
Sunny ji.
Mishra, sir.
Sir, I have provided you, ma'am, I have provided you co-host rights. You can share your screen now.
Sir, I have just logged in with my PC, sir. Hitherto, I have been in with the mobile, sir, because my presentation is in my PC.
Ma'am, then raise that hand. Then.
Okay, sir. I'll do that, sir. I'll do that.
Yeah, since you are using one phone and you are presenting on another device, you have to get access to both the devices.
Sir, I have shown the thumb, sir. I have shown the thumb.
What's your name, ma'am?
Dr. K. Shanta.
Dr. K. Shanta.
Dr. K. Shanta, I have raised the thumb, sir.
Ma'am, I can't find it. It's the name which I have raised with is M. Krishna Karthik Chandra Bhushan Sinha.
No.
Currently, you are using which device? Yeah, now I have found it. Now I found.
Yes, sir.
It's reflected now at my space. Yeah.
Okay, sir. Yes, sir.
Ma'am, in that case, you have to disconnect one of your devices. If you are
yes, sir, definitely.
All the participants who are willing to share their screen.
Sir, allow me to share my screen, sir.
Yeah, I have provided co-host rights to both of your accounts. Now,
yes, sir. Yes, sir. I got it, sir.
Yeah, ma'am. I request all the participants who are willing to share their screen or present.
This is Dr. Shanta from St. Joseph's Degree College, Kurnool. Today I am trying to present a low-cost adsorbent for the removal of dyes from small-scale textile industry effluents. Usually there will be a pollution control measures will be taken for higher industries, but small-scale industries, we usually don't see all those measures that are followed. So I'm concentrating on the textile industries which make use of dyes. So for this, I have selected 2 adsorbents as my experimental method to remove the dyes. The low-cost adsorbents that I have selected are the sugarcane basage and leaves of gulmohar, which are freely available. And I have taken certain parameters like pH, adsorbent dosage, and the effect of time, and I have performed the experiment. And the 2 environmentally friendly, cost-effective and freely available adsorbents, namely sugarcane basage and gulmohar leaves, are used. Sugarcane basage and gulmohar leaves are composed of cellulose, hemicellulose, lignin, and small amounts of ash and waxes. These adsorbents are available in abundance. Moreover, they are non-toxic and biodegradable. The parameters selected are different doses of adsorbent, contact time, and pH. The discarded basage was obtained from sugarcane stall. It was washed, dried at 60 degrees for 48 hours in hot air oven. Dried material was made into fine powder, screened through 600 micron size mesh and stored. Gulmohar leaves were washed, dried, and ground to use as adsorbent. Methylene blue was selected as adsorbate and was produced from SD Fine Chemical Limited. A stock solution was prepared and the pH was adjusted by adding 0.1 m sodium hydroxide and 1 m acetic acid solution. Then 25 ml of the dye sample was taken from the stock solution and desired amount of the adsorbent was then added to the sample, and various parameters like time is maintained for 30, 60, 90, 120, 150, 180 and 210 minutes, and the pH range from 2 to 9 was selected. A range of 0.5 grams to 2.5 grams of the adsorbent was used. And
why the experiment go to result?
The gulmohar leaves, they showed a maximum adsorbent adsorbing capacities with 120 minutes of contact time at a pH of 7.5 and a temperature of 30 degrees. And what is observed is at 1.5 grams of dosage, it was found to be maximum. The dosage of the adsorbate was 1.5, and that shows the maximum removal of adsorbent. And in the case of sugarcane, it took around 2 grams of the sugarcane basage to show the same effect. So the various other parameters are also taken into consideration, like pH. It was found that 7.5 was the optimum pH for the Gulmohar, and 7 was the optimum pH for basage. And for 1.5 grams, we had a maximum removal of adsorbents, whereas for sugarcane basage, it was up to 2 grams. So it was concluded that Gulmohar showed a better way of removing the adsorbent from the effluents. And not only that, it was observed that it was very difficult to remove the adsorbed substance, that is dye stuff, from the adsorbate, because there was a strong hydrogen bonding of this methylene blue with these adsorbents. So I think this will give a very useful way for all those small scale textile industry people to remove the dye stuffs from the effluents before they allow these effluents to merge with the water bodies. Thank you very much.
Thank you, ma'am. Thank you. I request all the participants to avoid details of experiment. Now, Mr. M. Prakash, Mona Parida, Vridhismita Sharma, P. Arthi. P. Arthi is there. Are you prepared to present? Dr. P. Arthi, are you getting my sound?
Participants, you are requested to raise your hands if sir is calling your name, so we can provide.
Once I call all the name, and I wish to call all the names, so that if you are present, then I will call again. First name was A. Anand Babu, other was Amrita Chakravarti, presented. D. Nageshwar Rao, D.T. Sakare, G. Muruthan. G. Muruthan is there. Are you presenting the paper? G. Muruthan ji. Govind Prasad. Govind Prasad. Jay Prakash. K. Kavi Priya, Kedar K. Raut, M. Krishna Karthik, M. Prakash, Mona Parida, Mridhismita Sharma, P. Arthi,
Hello, Mohan sir. Sir, sir, please do one thing.
Yeah.
If we can write their names in the chat box, then it will be more comfortable for them.
Yeah.
Participants, sir is writing your names in chat box. You can just directly ping yes or no, or then I will be mute. Then I will be unmuting you.
Mridhismita Sharma is present. Mridhismita Sharma is present. Sunny ji, please unmute him. Govind Prasad facing problem to the network. Mona is there, no?
I thought time is very less, so I just cut shorted my presentation, sir. Otherwise, I would have given.
Yeah. R. Amulyam, VVKP L. Murthy, Vasti Gyan Vijendra Singh Vayu Rathor. Aniji, please unmute. Mridusmita Sharma. Mridusmita Sharma. G. Muthu Raman is ready to present.
Yes, sir.
Please.
I am ready.
Dr. G. Muthu Raman, please present.
Yes, I am ready. Okay.
Sir, G. Muthuraman sir is here. Sir, are you going to present?
Yeah.
Sir, I have provided him.
Yes, sir. I am going to present.
Yeah, he is ready.
Yes. Is it visible, sir? Screen is.
Yes, sir. Your screen is visible.
Hello.
Sir, your screen is visible.
Visible. Please go on.
Okay. I will. Okay. Yes. So I'm from Presidency College. So the topic is the removal of the organic contaminants from the tannery effluent, removed by the UO method. UO is one of the method, that's the electro-oxidation method. What is the electrochemical reaction? The electrochemical reactions, that's the electrochemistry. The electrochemistry, the chemical process that causes the electrons to move. So since the electron is moved, the electricity is produced. There is a two type of the reactions. One is the oxidation reaction, another one is a redox reaction. That reaction is simply called the redox reactions. So what is the EO? EO is a electro-oxidation. Here, the electrode where the oxidation occurs, and the cathode, the electrode where the reduction takes place. So the anode oxidation and the cathode is a reduction. This is our experimental setup. I will show this is our experimental unit setup. Entire setup. This is our entire setup. This is the actual setup. This setup is installed in the one of the industry. The industry is in the Chennai. The area is a Chromepet. There is a ETP is there, effluent treatment plant. In the industry, they are collecting the tannery effluent. From the tannery effluent, we collect the tannery effluent. The instrument is we done some kind of the pilot study. So effluent we have taken here. This effluent we have taken here. The effluent is treated by the UO. That's the anode and cathode is there. We passing the electricities. After the passing the electricity, we have checked the organic contaminants. The organic contaminants, especially the organic contaminants, COD and BOD and TOC, total organic we checked it. And the here, why we have chosen the EO? The lot of the methods are available to remove the organic contaminants, the COD and the BOD. The previous speaker spoke about the adsorbent. This adsorbent can be used to remove the COD, organic contaminant. But the problem is the adsorbent causes the huge amount of the sludge, and the disposable problem is starting here. That's why we have chosen the EO. This is where, and similarly, the fluctuation, coagulation, membrane-based nanofiltration, these other processes are already available to remove the COD, and there is a pros and cons there. So that is why we have chosen the EO. In the EO, we have used the energy efficiency, automation, cost effective. Comparing to the other method, we are using the this method. Here we have chosen the tannery water. Some important parameters we have analyzed. The important
please
parameters.
Conclude, sir. Please conclude.
Yeah. The important parameters are the parameter analyzed are TOC. TOC, total organic carbon. This is total dissolved solid and free chlorine. COD, chemical oxygen demand. BOD, biological oxygen demand. Chloride, sulfate, TKN, sulfide, nitrate. But now in this study, we have checked only the total dissolved solid, TOC and COD. Three parameters we have checked. The three parameters, the tannery effluent, These are the instrument used. Ternary effluent is a contain the high amount of the COD. That's the
The sound is not audible.
No. I'm not getting your sound.
Muthu sir, please, Raman sir, please unmute yourself.
Okay. Now it's audible?
Yes, sir, you are audible now.
These are the parameters that are analyzed: TOC, TDS, and COD. So other parameters we are not checked. So because of the time concern. So the TOC is a total organic carbon, and TDS is a total dissolved solid, and COD is a chemical oxygen demand, and BOD biological oxygen demand. The textile effluent, the ternary effluent contains a huge amount of the COD, that is 2000 milligram per liter it contains. And the TOC is nearly the 2500 milligram per liter TOC contained. After the treatment of the EO treatment, the COD and the TOC level, it has been dramatically decreased. Nearly 75 to 80% of the COD, it has been reduced. And similarly, the TOC also 75 to 78% TOC, it has been removed. But we have to choose in future study, we have to choose the different kind of the anode and cathode. We have to choose, we have to select it.
Okay, thank you, sir.
Thank you, sir.
Mridusmita Sharma. Are you ready? Mridusmita Sharma, are you getting my sound? Yeah, you are allowed. Shaniji, please see Mridusmita Sharma. He's ready to present paper. Thank you,
Sharma, I have
Ramanji.
provided you co-host rights. You can unmute yourself.
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Sir,
Please go ahead.
Sir, am I audible?
Yeah, you
ma'am,
are audible. Please share your screen.
Sorry, 1 minute, sir. Just a minute.
Yeah, go ahead.
1 minute.
Oh.
P. Aarthi is there. P. Aarthi. P. Shabana. R. Amulyam. BBKPL Murthy. Vasti Gyan, Vijendra Singh, and Vayu Rathor. If you are present, please raise your hands and be unmuted. Be ready to present. Mridusmita, please be fast. কি নাম হচ্ছে PPAD रहते हैं। I think I should go ahead. Sarma is preparing for the presentation. P. Arthi is there?
Yeah, sir, she is here. I am allotting her with course rights.
Yeah. P. Arthi, please.
Arthi ma'am, please share your screen.
Okay, sir. Okay. Okay. Which one shares? Share. Hello, good afternoon, sir. Am I audible?
Yeah.
Am I audible, sir?
Yes, yes. You are audible.
Yeah, good afternoon, one and all present here. I'm Dr. Aarti and working on SRM as Assistant Professor in Department of Chemistry, SRM Institute of Science and Technology, Ramapuram campus. Okay, first I would like to express my thanks for giving such opportunity. And my title of this work is Theoretical and Biological Studies of a Pendenton Heteroleptic Copper-2 Phenolate Complexes. Okay, so in this paper, I have synthesized 6 heteroleptic pendenton complexes. I focused on the biological applications. I will study the DNA binding studies in fluorescence and UV spectroscopy, and is under study by the PBR322 DNA, and cancer cell lines activities, a study by HPEG2 cancer cell lines, human liver adenocarcinoma cell line. So, important class of molecules and multidisciplinary researcher. So, the biochemistry interdisciplinary science is working in different areas like chemistry, biochemistry, biology, medicine, and agriculture. So the coordination vital role, that is metal complexes is fine, but also in the catalysis in our researchers is fully focused to the replaces the platinum-based platin, oxyplatin, and metaplatin is plays the very vital role, and platinum-based drugs by the non-platinum-based drug, especially the transition metal complexes, shows the better efficacy than compared to the other metal ions. So coordination compounds, so they are attracted due to the important role in the various fields such as catalysis, material science, encapsulations, and biochemistry. So the phenol-based ligands, it's a bind with the metal complexes, plays a very key role in the development of coordination chemistry, and due to the ease of formation and unique structural properties and activity. So the DNA binding metal complexes, so the DNA interactions of, so in our work is fully for synthesize the phenol-based metal complex for applications in biotechnology and medicines, bind to the adenine thymine or the guanine cytosine residence, and DNA cleavage studies. So the plasmid synthesized complexes are studied under the PBR. Cleavage has been achieved by targeting the basic components of DNA such as phosphodiester linkages and deoxyribose sugars or nucleic bases. And cytotoxicity activity. So there are 2 types of the cell death. The one is necrosis, the other one is apoptosis. So the necrosis means is the unprogrammed death of cells and the living tissues, and the apoptosis, the process of programmed cell death. So
are not audible.
Evaluated. So in our paper is fully the complexes is further evaluated by MTT assay, and I have synthesized totally complexes. So the copper to first Am I audible, sir? Now it's
Yeah, audible, but be fast.
Information is regarding the coordination behavior of the and ligand to the methanation ion. The mass spectroscopy is provide the structural informations of the complexes, and UV visible spectroscopy. Yeah, I'm getting the regions around the 675 to 750 is provides the coordinations behavior of the ligand and the metal. And the CV cyclic voltammetric studies the reductions. Yeah, I'm using the copper metal complexes. It clearly shows the reductions, copper to reductions. And next one is the DNA cleavage studies. Yeah, and my complexes able to cleave the PBR3 complexes. And cytotoxicity studies is carried out by using the human liver adenocarcinoma cell line, HBG2 cell line. So finally, the conclusions of Merck. Totally, I have synthesized 8 saline diamine-based mixed copper-2 complexes is fully characterized. The binding studies is provides the additional information. The strong support the partial intercalations with the minor group binding. Thank you, sir. Thank you. Thank you so
Okay,
much.
thank you. Thank you. Thank you very much. Now, VVKPL Murthy.
Thank
VVKPL Murthy. Are you going to present?
Sir, I have provided co-host right to Murthy sir. Murthy sir, please unmute yourself and start presenting yours. Murthy sir, are you available?
Yes, sir. I'm available, sir.
Yes, sir.
Is it
Please,
audible?
Yeah, you're audible, sir. You can start presenting yours.
Thank you. Yeah, I'm sharing, sir.
Vasti Gyan, be ready.
So, first of all, my name is Murthy. I would like to thank the respected organizers from ACT for organizing this international webinar and the respected chair for this session. Thank you for the opportunity, sir. I am highly thankful to my research supervisors, Dr. S. Machraju, sir, and Dr. P. Shyamala, madam. With this, I will present the present topic, that is on groundwater quality evaluation to verify their suitability for suitable applications. So, in this topic, groundwater is a significant source for drinking and domestic utilities. In the present scenario, the groundwaters are contaminated due to anthropogenic activities. Industrialization is highly essential for the advancement of mankind, and it may influence the natural components of the environmental components like soil, water, and air. So, keeping in view, the present study is focused in the nearby areas of industrial area of Nakapalli, Mandal of Visakhapatnam district of Andhra Pradesh. So, this is the location of the sampling area. So, this is a huge industrialization area. So from this area, I collected the samples. So the groundwater samples were characterized for physicochemical analysis by adopting the standard analytical procedures prescribed by BAS for the parameters like pH, EC, TDS, total hardness, total alkalinity, calcium, magnesium, chloride, sulfate, nitrate, and fluoride ion concentrations. So these are the results I got. So this is the result table. So the pH is varied from minimum value 7.1 to the maximum value 7.81. So TDS value ranges from 485 to 2790. So EC values range from 683 to 3930. Total hardness value ranges from 220 to 890. Total alkalinity values ranges from 415 to 835. Calcium ionic concentration ranges from 70 to 180. Magnesium ion concentrations range from 9.76 to 114.68. So fluoride ion concentrations range from 1.2 to 2.65. Chloride ion concentration range from 40.5 to 1297.47. Nitrate ion concentrations range from 37.1 to 408. Sulfate ion concentration range from 28.3 to 276.57. Phosphate ion concentration range from 0.1 to 0.2. So the results, the research results revealed that the pH values range from 7.1 to 7.81 with an average of 7.49 reveals the suitability of these waters for drinking purposes with respect to pH values, while the TDS values ranges from 485 to 2790 ppm. The higher values of TDS and corresponding higher concentrations in majority of the higher ionic concentrations in majority of the samples reveal that these waters are not suitable for drinking purposes. So with these results, I am concluding with the conclusions. The analytical results reveal that the waters are chemically contaminated due to higher concentrations of several water quality parametric values. The waters in the study area are to be treated properly by applying suitable advanced filtration techniques for consideration of these waters for drinking purposes and domestic purposes. So with this, I'm concluding. Thank you, one and all. Thank you for the opportunity.
Thank you, sir,
Thank you.
for concluding in time limit.
Yeah, thank you, sir.
Vasti Gyan is present there. Vasti Gyan. Vijendra Singh ji. Vijendra Singh. Y.U. Rathor. S. Arul Murugan. He is present probably. Are you ready to present? Anyone who can present paper at present, please.
Sir, we have M. Karthik Krishna. Krishna Karthik, he has raised his hand. I'm unmuting him.
Yeah.
Now he has withdrawn his hand. No issues.
Yes, M. Krishna Karthik. Yes.
Sir, he has withdrawn his hand.
M. Krishna Karthik, are you ready to present?
Krishna Karthik, you are unmuted. Are you willing to present the paper? Hello. Am I audible? M. Krishna Karthik. Sir, are you willing to present your paper? If any one of you participants available in this meeting are willing to present your paper, you can write your name in the chat box. I am checking the chat box. If you are willing to present your paper, just...
Yeah, anyone can present. Anyone?
Sir, there is a name called Naveen Sharma, Naveen Kumar. He's asking, my name is Naveen Kumar. Tomorrow will be my turn, or today I want to confirm.
No problem. Naveen Kumar.
Naveen Kumar.
Yes, Naveen Kumar. Can you present at present? Ready to present paper? Mridusmita.
Yes, sir. She is also. Mridusmita is available. She can present her paper now.
Yeah. Why not? Naveen is also. Naveen can present paper.
Mridusmita, ma'am, please unmute yourself. I have requested you to unmute yourself. Yeah.
Just a minute.
Sir, just a minute. Sir, am I audible, sir?
Yeah, you are audible.
Please share your screen.
Please allow me share the screen. Sir,
Ma'am, please wait.
Share the
Please wait for a while. I'm allowing you the credentials.
Okay. Thank you, sir.
Yes. Now you can share your screen.
Yes.
Yes, sir.
Naveen Kumar, are you willing to share your presentation now or tomorrow? You are being muted. Please answer to us.
Yes, sir. I will today present. I will.
Okay. After ma'am, you can. After Sharma ma'am, you can present your presentation.
Sir, my screen is visible, sir. Sir, is my screen visible? Sir, here shows some unsupported error, sir.
Ma'am, that is most probably because of your system issue. We can't do anything in that case.
1 minute, sir. Just Sir, here shows some unsupported document type. Please select.
Ma'am, you are selecting an unsupported document type. You have to select a proper document type. Sir, we have Kajal Kumar Chakrabarti.
Yeah.
Kajal Kumar Chakrabarti, she is willing to.
Hello him.
Yeah.
And then MK Karthik also. He is also ready.
Don't worry, but Smita, please.
You.
Thank you, sir. So I'm very interested to present here.
No problem. You can present. No. Don't be worried.
Yes, sir. Kajol Kumar Chakraborty present here. Yes, I'm trying, but here there are continuously some.
You will get time. You will get time tomorrow also. No problem. Yes, Karthik ji, please.
MK Karthik.
Thank you.
Hello, sir. May I audible?
Yes, sir. You're audible. You're audible.
Okay, sir. May I share the screen, sir?
Yes, sir. Yes. You can share the screen. Smita ma'am, please mute yourself. Karthik sir is presenting. I request you to please mute your screen yourself. Yeah. Thank you.
I am MK Karthik, research scholar of JNTU UK under the guidance of Dr. PVS Machraju garu and Dr. S. Sachivani madam. So my present research topic is impact assessment of metals and pesticide residues on groundwater near agricultural activity areas. So agricultural runoff mainly contaminate the groundwater sources. So I have chosen one study area where the hectic agricultural activity is going on. So water is essential to life and it plays a crucial role for the development of any country. So application of fertilizers and pesticides enhance the agriculture production, but result in direct and harmful impact on water quality. In recent years, higher contamination with arsenic in groundwater is recognized as crucial environmental problem. So the presence of inorganic arsenic in the environment arises due to natural and anthropogenic activities like weathering of rocks, biological activities, geochemical reactions, and volcanic emissions. So my research work is mainly focused on characterization of heavy metals and pesticide residues. So here the metal ions identified are chromium, manganese, iron, cobalt, nickel, copper, zinc, lead, mercury, and arsenic. So these all are characterized by using ICP OES technique, inductively coupled plasma optical emission spectroscopy. And the pesticide residues are characterized by using GCMS, where the pesticides identified are monocrotophos, phorate, phenyltrethione, lambda-cyhalothrin, atrazine, lindane, diazonon, chloropyrifos, methyl parathione, alachlor, heptachlor, dicophol, parathione, phosphomidone, aldrin, and dialdrin. These are the pesticides identified in the study area. And the metal concentrations of groundwater near agricultural activities areas are presented in this table. So where the higher concentrations of some metal ions are present. So here, by seeing this table, the groundwater samples are analyzed by using ICP OES, where in sample KP3, the copper ion concentration exceeded the guideline value 79.68 microgram per liter. In sample KP1 during post-monsoon season, all the metal ions concentrations are in permissible limits. So during post-monsoon season, in samples KP2 and KP3, the metal ion concentrations of arsenic exceeded the permissible limit, that is 16.65 and 12.63 microgram per liter. So these are the values exceeded as per WHO standards and Indian standards, while the concentration of other metal ions like chromium, manganese, iron, cobalt, nickel, copper, lead, zinc, mercury are within the permissible limits. So finally, the results showed that the concentration of metal ions, chromium, manganese, iron, cobalt, nickel, zinc, lead, and mercury in groundwaters near agricultural areas during pre and post-monsoon seasons were found to be within the guideline values, and the concentration of arsenic and copper ions are observed at higher levels compared to the guideline value during pre-monsoon season. And during post-monsoon season, the concentration of arsenic metal ion is crossed the guideline value. So finally, the conclusions are, in case of pesticides concerned, lindane and diazonon are found to be more compared to the standard values. So the results indicate that the waters are contaminated by metal ions, mainly arsenic and copper, and the pesticide residues lindane and diazonon. Hence, the waters are to be treated properly for consideration of utility. So, thank you, sir. Thank you for giving this opportunity.
Thank you. S. Arul Murugan. S. Arul Murugan. Are you ready to present your paper?
Murugan sir, you have course rights. You can share your screen and start presenting your paper.
S. Arul Murugan, are you not ready? Kajal Kumar Chakravarti, are you ready?
Yes, sir.
Please, yeah. You are Kajal Kumar Chakravarti?
Yes, sir.
Yeah. Please share and conclude in 3 minutes.
3 minutes. I am Kajal Kumar Chakravarti. Good morning, everyone present here. The title of my research work is mitigation of arsenic and fluoride from groundwater or surface water by the adsorption and filtration through the special laterite soil with using atomic absorption spectrometer or electrophotometer. Everybody has birthright to drink clean, safe, purified, germless, contaminantless, potent water. The main source of our drinking water are the river and groundwater, which is available to the people by the tube and the well. Unfortunately, most of the region of the Ganga Brahmaputra plains are affected by arsenic and fluoride ion, especially in UP, Uttarakhand, Uttaranchal, Jharkhand, Bihar, Assam, West Bengal. The water of the tubes and the wells of this region have been reported to carry arsenic and fluoride beyond the permissible limit. Arsenic and fluoride percolates and mixed with groundwater via natural and multiple anthropogenic pathways. Many health hazards are associated with exposure and elevated level of the arsenic and fluoride ion are carcinogenesis, lungs and urinary bladder cancer, black foot diseases, diabetes, internal maladies, gastrointestinal and melanin disorder, skeletal and dental fluorosis, urinary tract infection, nerve and muscular malfunction, and sometimes it causes ultimate death. 50.4 million of the people of the 3,417 villages of 140 blocks of 12 districts of West Bengal are affected with the extremely high level of the arsenic contamination, and approximately 25 million of the people in 2013 district of India are affected with fluorosis, and nearly 66 millions, including 6 million child below the age of 14 years, are at risk according to UNICEF. For the removal of the arsenic and fluoride, many technological methods are there, but no one is fruitful in large-scale uses. In the present study, a new technological method based on the principle of the filtration and adsorption and using a special laterite soil have been adopted for the mitigation of the arsenic and fluoride ion from the water sample of the Hooghly and Paschim Mednipur, North Chobbish Pargona and Bankura district of West Bengal. This method is less expensive, easy to handle and safe. Amount of the arsenic and fluoride are to be detected before and after the water sample treatment by atomic absorption spectrometer or electrophotometer. It will be observed that the amount of the arsenic and fluoride ion in this treatment water sample are within maximum contamination level of the arsenic and fluoride ion. The maximum contamination level of the arsenic is 10 microgram per liter, and the maximum contamination level of the fluoride ion is 15 microgram per liter according to World Health Organization and the Environmental Protection Energy. Thank you.
Thank you, sir. S. Arul Murugan, are you ready to present your paper? Amit Kumar. Are you ready to present your paper?
Hello.
No one is there now?
Hello.
Yeah.
Sir, audio is visible?
Yeah. Audio is audible and you
audible. Sorry, sir.
screen. You are audible.
Okay.
Dr. Archana Singh can present your paper tomorrow also, no problem. Yes. Amit ji,
Amit,
please.
Amit Kumar, you have the co-host rights. You can share your screen.
Visible, sir?
In last call to Mona Pipra. If you wish to present, please be ready.
Amit, your screen is not visible to us. Can you share your screen?
Visible, sir?
Yeah, now it is visible. Now it's visible.
So I'm research scholar. My poster presentation on the topic simple and highly efficient synthesis of novel fluorinated 4,6-disubstituted aminopyrimidine using cadmium acetates. As we know the importance of 2 aminopyrimidines that is available in various biological activities, and there is a approved drugs of aminopyrimidine that subunits. You can see aronexils, thylamine, amzardarine, or bruciferin. So these are the approved drug for aminopyrimidine subunits. So my importance of work is we have incorporate fluorine atoms in 4,6-disubstituted aminopyrimidine. So we have examined with the various metals, metal salts with the fluorinating reagent NFSI. So this is the synthesis of 5-fluoro-4,6-disubstituted diphenyl pyrimidine 2 amines with the help of NFSI and this cadmium acetate, which activate this 5th positions of carbons, and then after that we incorporated the fluorines with the help of this optimization reaction condition. Then after that we have synthesized the various derivatives that is a substituted fluorines, and these are the data for proton NMRs that we have a region of 12 protons, that is NH2 for around 6.7 ppm, and this is my 13C NMR. This is the fluorine NMR peak for a single fluorine for incorporation of fluorine, and this is my HRMS. So conclusion, we have incorporate the fluorine atoms in suitable 5th position of 4,6-disubstituted aminopyrimidines. These are my reference, and this is my publications that is accepted in 2020. Thank you, sir.
Thank you, Amit ji. Thank you. So I hope now no one is ready to present paper today.
Hello, sir. Hello.
Yeah.
Good afternoon, sir. I'm Arul Murugan.
Yes, yes. I called your name many times. Please.
Thank you.
Dr. Shashi Balaji, there will be no presentation on 1st December. If you wish, you can present tomorrow.
Sir, we have Meenal Gupta. Meenal Gupta ji is available. She is willing, I think. Yeah.
She can.
Gupta ma'am, I have provided you co-host, right? You can unmute yourself and you can.
Thank you, sir.
Yes, ma'am.
Am I audible? Yes,
yeah, ma'am, you're audible. You can share, present your screen.
I am sharing my present screen. Okay. Sorry. There is some technical problem. Just 1 minute. Please wait.
मैं कुछ नहीं करा, मैं बताती हूँ बस।
कहाँ? Yeah. Share.
Subhasish Chattopadhyay, are you ready to present?
Yeah.
Right now?
My screen is visible, sir?
Yeah, it is visible. Go ahead.
Yeah. Thank you, sir, for giving me this opportunity. I am Dr. Meenal Gupta, Assistant Professor from Government PG Arts and Science College, Ratlam, Madhya Pradesh. My topic is potential anti-cancer phytoconstituents from natural products. Since in the nature very beauty of compounds are found with various functional group having diversity of the functional groups are present in that compounds, maybe ketone, alcohol, aldehyde, and other types of the steroids, alkaloids, terpenoids, flavonoids, carbohydrates, and like this. And for we want to isolation of the phytoconstituents, we have taken selection of the plant material, and after we select the plant material, we have choose the extraction technique, and after extraction, if we prepared, then we have choose the rotary evaporator to concentrate the extract, and after that we use different types of identification techniques for identify the compound using 1D and 2D and NMR, mass spectrometer, thin layer chromatography, column chromatography, and like this. And various compounds, maybe alkaloids, terpenoids, flavonoids, proteins, carbohydrates, they are isolated. And for after that, we will investigate it through the model in vitro and in vivo studies, and they will be identified at the target area which one is the bioactive for that purpose. Since the major problem in the nowadays, the pandemic problem is COVID-19, but cancer is again a very global problem from ancient to nowadays, and about 18.1 million cases have arisen at that time. And when cancer cell can initiate and spread in different tissues in the part of the body, prostate cancer, colorectal cancer, stomach cancer, and since various types of cancer, how cancer occurred. So due to uncontrolled proliferation, loss of function, invasiveness, and this is the normal cell cycle. This is the M phase, G phase, G0, G1, S, and G2 phase. But when interruption takes place in these type of cycles, maybe environmental and maybe the lifestyle of us, so they maybe change the cell irregular in manner, and the cell division will be irregular, and they cause maybe cancer. So there are some also harmonic changes maybe occur, and they give the path of carcinogenic path. These are the some compounds: curcumin from Curcuma longa, berberine, and beta-alanine, and this is the lycopene. This is from vitamin B and A source, carrot and paclitaxel. They are regulate this cancer causing growth factors and reducing the production of reactive oxygen species. They have various inflammation occur in our body, and therefore NF, Kb, kappa particles also increase in signal increase in our body. But by using these natural products, we can regulate the cell cycle of us by using these key signals. They can be inhibited. So therefore these are the medicinal plants. They causing anti-angiogenesis activities: ashwagandha, curcuma longa, that is haldi; barberries, that is produced berberine; calotropis procera, that is
तो मैम वो YouTube पे अवेलेबल है मैम, ये मैंने आपको लिंक भी भेज दिया है, तो वो लास्ट में जाके है, ये तो सेव रहता है।
मीनल मैम आप खुद को अनम्यूट करिए जी। ठीक,
लास्ट में अभी तो लाइव ही चल रहा है, मैम वो लिंक मैंने आपको दे दिया है, आप देख लेना।
I am already unmuted, sir. These are the various plants products. They are giving the anti-cancer compounds. Please change the slide. And the new, that is the various anti-cancer compounds like some mistake, some okay. This is the Cantharanthus roseus. This is the Sadabahar plant, and this grow in around us in the all environment of our India. They isolated from these plants, isolated vincristine, vinblastine, and vindicine. They are alkaloids, and in general they are used for anti-cancer, and anti-cancer compounds from green tea also have been identified, and some from Nigella sativa some compounds are also identified and categorized as anti-cancer compounds. This is the flavonoid molecules. Flavonoids generally present in green tea. So therefore, by using green tea, by taking the extract of maybe giloy, maybe Cantharanthus roseus, and tulsi, aloe vera, ginger, and other around in our nature in us, we will protect from the antiviral and anti-cancer. We will protect from viral attack or maybe cancer attack, and we also regulate our lifestyle also. Okay, thank you very much.
Thank you, ma'am.
Thank you, sir. Thank you again and again.
Prasad, are you ready to present paper? Govind Prasad. Hurry up if you are ready to present paper. Unless we are going to.
Sir, I'm Idushmita Sharma. Sir, can you give me a chance? Sir.
Are you ready now?
Yes, sir. Sir, I'll try for last.
Start. Hurry up.
Yes, one.
Are you visible?
Sir, am I visible, sir? Sir, my skin is visible. Yeah?
Yes, visible. Go ahead.
1 minute, sir. Yes, sir. So, good afternoon, everybody. Today I am going to present about periodic monitoring of copper and zinc in stepwise tree infusion of Methi collected from Upper Assam region, India. And now everybody knows that tea is a most popular, widely taken non-alcoholic beverage, and it is a tea. Camellia sinensis is a perennial acidophilic crop. That is, it mainly grows in acidic soil. Therefore, it has a tendency to absorb soluble trace elements from the soil. But one cannot consume Methi as a whole. He has to take it as a water extract that is called tea infusion. Therefore, we can say that tea infusion is a very good source of many trace elements. And it is beneficial. These trace elements is beneficial to human body if it is taken in limited amount. 1 minute, sir. But the amount of trace element in tea infusion is influenced by many factors. That's solubility of that particular element, infusion preparation time, element content in original tea leaves, temperature, extraction method, pH of water used, and use of fertilizer, and one most important factor is climate. And now India is second highest tree producing country after China, and Assam is the only state which contribute more than 50% to its total production of India. And in Assam, there's two districts, Dibrugarh and Tinsukia of Upper Assam, contribute more than 40% to total tea production of Assam. But in recent time, it has shown that there is some Assam tea quality and quantity has slightly degraded. It may be due to many factors. Therefore, it requires periodic analysis is very essential. Therefore, in my present study, I collected some Methi samples from maximum 35 samples, Methi samples from these two districts, that is Tinsukia and Dibrugarh. and they are analyzed for mainly
Skip
two
experiment and go to result.
Yes, experimental result. And here these are the steps of preparation of tree infusions. First, 2 gram of TMAT sample was taken, and 50 ml of distilled water, boiled distilled water, and then it is allowed for 5 minutes, and after then they are filtered and kept in refrigerator by adding chloroform. And for analysis, we prepared 4 standard of this concentration along with the blank, and then they are analyzed in atomic absorption spectrophotometer. Here you can see the side-by-side box plot diagram for copper. Copper, and here copper concentration in first infusion, second infusion, and third infusion, and here the zinc concentration in the first, second, and third infusion. And zinc concentration is found from in first infusion, it is found from 8.50 to 73.50 mg per liter. In second, 6.75 to 18.25 mg per liter, and in third infusion 2.25 to 9.23 mg per liter. And similarly, copper concentration in first infusion 1.45 to 7.38 mg per liter, in second 0.53 to 2.68 mg per liter, and in third 0.15 to 1.33 mg per liter. And here in all these samples, first infusion contains a higher concentration of zinc than that of copper, and both concentration is decreases from first to second, and then second to third. And these results highlight the deliberate decrease of copper and zinc concentration from first to second, and then second to third. And all these reported levels of copper and zinc in tea infusions were in agree with other studies. Therefore, these results highlight these results. I think this is very beneficial to maintain the quality of state tea, and this type of periodic study has immense need to maintain the quality of Assam tea. Thank you, sir.
Thank you very much. Govind Prasad, last presenter, Govind Prasad.
Yes, sir.
Are you willing to present?
Yes, sir. I am audible, sir.
Yeah, you are audible. Hello, sir. Bus last is going.
Sir, Vasti ma'am is there. She's also willing.
Today, I hope I not possible now, no?
Okay.
Because you have a ECM now. Tomorrow, everybody if want to present, tomorrow we shall give time. I called Vasti Gyan many times, but she was not ready at that time. Govindji, please hurry up.
ACCT है या
ACT.
ACT.
Yes, sir.
Yeah, go on, go ahead.
Some problems. Can I? Excuse me, sir.
Hello,
Sir, I'm facing some problem. Can I present tomorrow?
you are Govind.
Yes, sir.
What problem you have?
Sir, my mobile is not.
Okay, no problem.
Can I able to present, sir, tomorrow?
Tomorrow you can present, no problem.
Okay, sir.
Gyan Vasti, are you ready? Okay, thank you. Now all the participants are requested to be present for tomorrow's session. Tomorrow, any participant who want to present paper, please be prepared for tomorrow. Okay, Pare sir. Hello, Pare sir, are you hearing me? Prabhu sir.
Yes. Hello.
Hello. Now it's okay.
Yes. I think we can start the EC.
Can you hear me?
Yes.
How many have joined us, sir? Should we wait? How many have joined?
No idea.
Good afternoon, sir.
Please present.
Professors, good afternoon. This is Helen. I have joined.
Hello.
Yes.
Good afternoon, sir.
Good afternoon.
Oh, Helen have joined.
Yeah. No, I'm here from the morning.
Yeah.
I'm just telling.
Professor Mishra. Professor Mishra. Can we tell Sunny, those who are not in the, I mean, now it should be EC meeting will go on, na?
Yes.
So
Others
the other
can leave.
But I see the people are there. No, we have to check, that only the EC members are there, I mean, like that.
Sir, these people have to quit the meeting if they are not the EC members?
Yeah, should definitely, yeah.
Okay. Participants, you are requested to leave the meeting
because
for now.
We are 134, yeah.
Okay. All the participants other than the EC members are requested to leave the meeting. You can join us tomorrow. From now onwards, EC meeting is going to conduct on this.
Yeah. Just 1 minute. 1 minute, Sunny. Dr. Mishra. Dr.
Mishra sir, you are muted. Please unmute yourself.
No, Dr. Prem Mohan Mishra.
Sir,
Yeah.
Sunny I wish you should end the meeting and start a fresh meeting of EC.
Okay. No, but at least, because people are leaving, slowly, and there are still 170, the participants are there, no? So at least we need to tell them that we are going into the EC meeting of SET, and tomorrow they can just join our next session.
Yeah.
At least, so I request on on my behalf that the Association of Chemistry Teacher Executive Council is going for a meeting, and today's session is over. So we are looking forward to meet you tomorrow. And I just welcome you again, and I invite you for tomorrow's sessions. And thank you for attending today's session. So today's sessions are over, and SET Executive Council is going into the meeting now. Prabhu sir, you are not audible.
Hello.
Okay.
First, we should know how many members of EC are present.
Yes, sir. We should know that. So at the moment, people are leaving it. There are still 95 participants are there, you know.
We'll wait for a few minutes.
Yeah, we wait for a few minutes.
Yeah.
Sir, should we stop the YouTube live thing?
Yeah, stop it.
Yeah, sure.
Stop YouTube live. Yeah.
Yes, yes.
Good afternoon. This is Man.